Good morning, all. I welcome you all to the third International Conference on Emerging Trends in Engineering and Technology, organized by Department of Mechanical Engineering, Sandeep Institute of Engineering and Management, in association with Institutes for Engineering Research and Publications. Institute of Engineering Research and Publication is a multidisciplinary professional organization dedicated to research and development within the field of science, engineering, and technology. IFERP is a preponderant body that has brought technical revolution and development of science and technology. The IFERP Forum constitutes of professional experts and oversees technical leaders. There is no stone unturned to strengthen the sphere of science, engineering, and technology. These days, IFERP is one among the leading publishers of research papers in its prime quality, peer-reviewed journals, Continuing and Analysis magazine. About the co-host. Hello. Sorry for the inconvenience. Sandeep Institute of Engineering and Management is in the scenic, eco-friendly, and conducive to study campus at an elevation of the Trambak Road, leading to one of the 12 renowned pilgrimage of Jyotirlings known as Tambakeshwar, abode of Lord Shiva at the foothills of Brahmagiri mountain range. SIEM is approved by All India Council for Technical Education, New Delhi Government of India, and affiliated to Savitribai Phule University of Pune. SIEM is committed to imparting quality education in an atmosphere that will ensure that its students are confident, self-motivated, and industry ready. Today, this goal, we are giving importance to qualified and experienced faculty for effective teaching, learning processes, equipping our laboratories with best-in-class machines and instruments, and developing overall personality of a student, with emphasis on strengthening the fundamentals of subjects, ability to work as a team, and with communication skill. There is a well-formulated regimen with a blend of theoretical learning and practical experiences. This enables the faculty to guide the students to learn tomorrow, today. Major achievements of a college: AC credited by NAC of UGC thrice, recently with B++ grade in 2017, recognized by UCG under 2F and 12B, permanent elevation with SPPU Pune, recognized as institutional member of National Cyber Safety and Security Standards, New Delhi, authorized training partner to NSD New Delhi at PMKVY TI Center, offering consultancy services to major government and private organizations, that is testing or evaluation or design, standing on first rank at Sai Baja, a national event for 80 vehicles, placement in AY 2021, SIEM students have performed well in placement, and there are 291 offers backed by students of all streams. The objectives of ICETE 2022 is to present the latest research and results of scientists, prefer students, postgraduate students, and research scholars and postdoctoral scientists. It is related to electrical, electronics, and communication engineering, and computer science and engineering. The conference will feature traditional paper presentation as well as keynote speeches by a prominent speaker who will focus on related state-of-the-art technologies in the area of conference. The intent behind the multidisciplinary international conference is to provide a common platform where academia, delegates from industries and domains from the various government and private universities and institutions can sit together and cherish about achievement so far, as well as deliberate upon futuristic approach along with major bottleneck. The deliberation will not only encompass all avenue of civil, electrical, electronics, computer science, and mechanical, but also through spotlight on positive and inadvertent impact of modern technology on society. I would like to welcome our honorable dignitaries, Dr. Sandeep Kumar Jha sir from Sandeep Institute of Engineering and Management. Welcome, sir. I would like to welcome the CEO of Technorate Group, Mr. Rudra Bhanu sir. Welcome, sir. I would like to welcome our honorable convener, Professor Dr. Dp Patel sir from Sandeep Institute of Engineering and Management. I would like to welcome the honorable co-convener, Professor Dr. Is Dubey sir from Sandeep Institute of Engineering and Management. Next, I would like to welcome our eminent keynote speaker for all over the globe, Dr. Sanjay Sethi sir, founder and CEO from Antar Dhawani, St. Joe's, Silicon Valley, California, USA. Mr. Fred Henry sir, President and Dacket Solution, Alberta, Canada. Professor Mohammad Fayad sir, full professor, St. Joe State University, CEO, San Francisco Bay Area, California, from United States of America. Dr. Nilaj Deshmukh sir, Dean and Head from Mechanical Engineering Department, Roger Institute of Technology, Vashi, Maharashtra, India. Thank you for joining us even during this pandemic situation. Imparting their expertise with us, I would also take this opportunity to welcome all our presenters from across the India, who has spared their valuable time in enlightening us with their latest research studies. I would like to welcome our honorable co-convener, Professor Dr. A.S. Dubey sir from Sandeep Institute of Engineering and Management to deliver a welcome speech. Dr. Anil Dubey sir did his PhD in Mechanical Engineering from Nagpur University. He is a fellow member of Institute of Engineering India, as well as life member of ISTE, member of IFERP and ISHRAE. He's currently working as a professor and head of Mechanical Engineering Department. He is an academic since 1998. From last 25 years, in his teaching with specialization in thermal engineering and energy auditing and renewable energy. He is recognized research guide in SPPU. He's also worked as a college examination office and successfully completed central assessment program of SPPU in past. He's currently serving as an associate editor, editorial board member, technical advisor board member, potential peer reviewer, and journal reference on at least 20 journals. He has participated in the more than 20 teacher training programs in reputed institute. He has published more than 35 articles in various conferences and journals at international level. He has served as a convener and co-convener for international conferences. He worked as designated reviewer for more than 20 plus international conference, as well as recognized as outstanding journal reference for numerous SCI and Scopus journal. Welcome, sir.
Okay. Thank you, Diya. Okay. A very good morning to all. It's a great pleasure to welcome you all for the inaugural session of International Conference on Emerging Trends in Engineering and Technology 2022. Honorable Chairman of Sandeep Foundation, Dr. Sandeep Kumar Jha, Academic Facilitator, Professor Pramod Karole sir, our beloved Principal Dr. Dp Patel sir, CEO of IFERP Rudra sir, all the keynote speakers, session chairs, my colleague, participants and listeners. It's a great pleasure to welcome you all. As you all know that this is the third consecutive session when we are collaborated with IFERP and organizing that international conference. That kind of conference is possible just because of the support and motivation from our management and also the support from IFERP and all the participants. When we talk about the conference, as we all know that that kind of conference, any international conference or national conference, the basic objective or basic motto is the knowledge sharing. To share the innovative things or innovative research or emerging research that took place in the various sectors. Since this is an interdisciplinary conference, so this forum is open to all the disciplines of engineering and technology. When I'm talking about the previous two conference, we started in 2020, 2020, collaborated with IFERP. That time we all know that we suffer through the pandemic, but pandemic taught a lot of things to us. One of the best outcome from that pandemic is now we shifted to virtual mode, and because of virtual mode, it is very much possible for the researchers, for participants to participate in that kind of event. So this time also we got very good response. We started in 2020. That time little bit we got more than 100 plus registration. Then last year 21, it's better than this, better than 20. And this time also we are doing well as compared to the previous two conferences. If I look at the outcome, especially when I'm talking about since it is organized by Department of Mechanical Engineering. So what we achieve, the department achieved through that kind of conferences, I can say that our UG students, I'm proud to say that almost 90% of our UG students publish their work. So they got the idea that what is going on the particular topic, particular idea. So they exchange their ideas, their practices with the other people. And every time they are getting some suggestions from the participants. Those are the part of that conference. The second outcome that earlier, if you look at the quality of papers also, that when we are talking about the UG students, we know that it is up to certain limitations are there. But because of this kind of conference, there is a confidence building among the students. And from last 2 years, we also improve the quality of papers, and few of our UG students publish their paper even in Scopus and SCI. So this is one of the good practice that I can say, which is to be followed by the Department of Mechanical Engineering at Sandeep Institute of Engineering and Management. Now, when I'm talking about the collaboration with IFERP, when we started in 2020, collaborated with IFERP, IFERP supported a lot. And because of that support from the IFERP, we reached to the entire corner of that world. Even we can say, even this time also, we got a good response from abroad, and we received the papers across the India. The coming 2 days, as if you see the agenda of that conference, entire conference agenda, there are 4 experts, keynote sessions are there, and those are the stalwarts in their area. So they are going to share their experience, their knowledge with all the listeners and the participants. Along with that, the session chair also providing some input and feedback to the presenters. So this is one of the good opportunity to learn from that conference, and it is learning for all of us. Even we as a department, we learn a lot from that kind of conference. So I once again welcome and congratulate to all the participants. Those are going to present their paper. And also I thanks to the all the experts, session chairs, and the IFERP for providing this opportunity to organize this type of conference. So coming next 2 days, today and tomorrow, these are the full of knowledge sharing and idea sharing. So with this, I conclude my speech. Thank you. Thank you to everyone.
Thank you so much, sir, for enlightening us. Thank you, sir. I would like to welcome Mr. Rudra Bhanu Satpathy, sir, CEO of Technorate Group, to give the welcome speech for the conference. Mr. Rudra Bhanu Satpathy, sir, is an entrepreneur, investor, philanthropist, founder, and CEO of Technorate Group. He had 10 years of experience in organizing scientific conferences. He completed his education in engineering from SRM University, Chennai, ME from St. Peter's University, Chennai, and he is pursuing his PhD in St. Peter's University, Chennai. His research interest includes image processing, antenna, and wireless network. He is interested in doing several socio-academic activities for the welfare of society. Under his guidance, IFERP and BioLeaks Worldwide became one of the fastest growing organizations in Asia. His organization received the Best Scientific Conference Production House of 2018 from ABP. With success knowing no limit, Mr. Rudra sir attribute his fame to teamwork and entrepreneurial spirit, which together has enabled transform to risk to opportunities to handle for ever-changing environment in education and technologies. His research interest includes imaging, image processing, antennas and wireless network, climate change and ecology, drug discovery and communal medicines, cancer and our battle, oral health, allied health science, technology for humanity are some of my concerns. Rudra sir, please, I welcome you.
Very good morning, everyone. Thank you, Dr. Dia, for this wonderful introduction, and it's really overwhelming for me to address this gathering. In fact, this gathering is all about the third international conference on emerging trends in engineering and technology that takes us back with the very strong understanding and strong connections and relationship we have with Sandeep Institute of Management and entire Sandeep groups of institutions as well. And under the leadership of Dr. Anil Dubey and Dr. Dp Patel, Honorable Principal of this esteemed institution, this could have been possible. I'm really grateful to both of them and the entire management of Sandeep Foundation for their immense faith and trust on IFERP, Institute for Engineering Research and Publication, and giving us this opportunity to serve the community, the technical community of Maharashtra. And under the leadership of our professional leaders, our institutional chapter members, our local ambassadors, our state ambassadors, IFERP Maharashtra has grown up to a successful venture, a successful unit of IFERP, providing uninterrupted academic services, even though in pandemic, to develop the capacity of researchers and higher education in state of Maharashtra. I'm extremely privileged, and I do feel glad to see you all in this virtual conference. Meanwhile, I do regret of my physical absence and not getting the opportunity to visit the campus and doing this conference for third time also in the virtual platform. We all are excited to visit this beautiful location, the divine location, the location of history and location of the glory, Nashik, where we have pilgrims traveling to Triambakeswar temple, an historical location that always speaks about the glorious tales of Shivaji Maharaj. Today, International Conference on Emerging Trends in Engineering and Technology is a brilliant platform with eminent speakers, thought-provoking, spellbinding researchers, and plenary presentations, as well as keynote addresses, and attendees and delegates gathering from nook and corner of India, as well as different countries. Esteemed dignitaries, revered speakers, respected chairpersons, management of Sandeep Foundations, my beloved students. I wish you everyone a warm welcome to this esteemed conference, and we have tried our level best to create a great scientific agenda that will be definitely fruitful for you. That implies us towards the first goal of IFERP, that speaks about promulgation of scientific educations and scientific knowledge to different locations, different regions, different countries, respective of their standards of being developed and developing. To make this conference worth of attending, we have speakers from different countries and session chairs from different locations and states. We do have some opportunities of publications, and I believe the quality of research presented here will be published in highly cited and highly well-indexed journals, including Web of Sciences and Scopus. Our editorial team is reviewing the articles, and the quality articles will be having a privilege of getting published. IFERP is providing institutional membership, institutional chapters, local chapters in different states, different colleges, so that this could be possible to create the vision of IFERP of integrating universities and educational institutions based in different countries, states, and provinces, where we have a common platform for research and sharing the knowledge. The second goal implies us about the capacity building. It's very important to focus and divert ourselves to create the capacity and develop the potential of researchers, even growing in grassroots level of the nation, so that they could deliver quality educations and research services. If we look into the categories of NAAC accreditation, our government is continuously revising the policies and criteria that has been emphasizing always on outer world interaction, where educationalists, researchers, and students must be given enough privileges, opportunities, and scope to interact with professionals all across the globe and think beyond the campus. And we help professionals to do so as well. I wish these 2 days of virtual conference will be a magnificent event and be a fruitful days by sharing your knowledge, and we'll have definitely great opportunity for scopes for learning as well as sharing your ideas and innovation. I wish everyone all the best and hope this conference will be meeting your expectation. Thank you very much. Wish you all the best.
Thank you so much, sir, for giving a valuable speech. Thank you, sir. Next, I would like to welcome our Honorable Convener, Professor Dr. Dp Patel, sir, to deliver his speech. Dr. Deepak Pandurang Patel, sir, is working as a principal in charge at Sandeep Foundation, Sandeep Institute of Engineering and Management, Nashik. Also, he is a Dean International Affairs at Sandeep Foundation, Nashik. He has an experience in the same university as a professor as well. Received prestigious Engineering Achievement Awards 2016 by Institution of Engineers, recognized for significant contribution in Institute of Electronic and Telecommunication Engineers, Nashik Local Center 2016. Innovative Research Developer and Publisher Award in 2017 in the Best Teacher category. Received Distinguished Educator Award in 2018 by International Institute of Organized Research. Received Young Principal Award 2019 by Sankalp Paper Limited. He is specialized in the area of wireless communication, cognitive radio, spectrum management. Welcome, sir.
Good morning to one and all, and thank you, dear ma'am, for nice introduction. On behalf of management of Sandeep Foundations, on behalf of Honorable Chairman Dr. Sandeep Kumar Jha, Academic Facilitator of Sandeep Group, Professor Pramod Karole, co-convener for this conference and Head of the Department of Mechanical Engineering, Professor Dr. A.S. Dubesar, I heartily welcome all the participants for this third international conference on emerging trends in engineering and technology 2022 which we are organizing in association with IFERP. Friends, as we know, every crisis presents an opportunity, and past couple of years provided an excellent opportunity for all the researchers to think about ideas that could shape the post-pandemic world. This pandemic not only a test of our resilience, but also of our imaginations. It is a chance to build a more inclusive, caring, and sustainable future for all us utilizing emerging trends in engineering and technology. Taking a part in international conference is a great way to meet like-minded people and forge connections with them. These lifelong friendships and professional acquaintance will come in hand to hand, not only for learning, but also about thinking the latest trends and disciplines in the area of engineering and technology. Emerging technologies have an ability to put a positive impact on our society in today's highly competitive and complex world. Friends, we are organizing this third virtual international conference in collaboration with Institute for Engineering Research and Publications, IFERP. I'm very much happy for our association with IFERP since last 3 years, because in 2020, when the world was facing extreme pandemic, the pandemic was at its peak, we have dared to organize the conference, and the conference was very successful. As already Dr. Is Dp told, we got more than 100+ papers for that particular conference. In year 2021, more than 300+ participants have presented their work in second international conference, ICETET 2021. And I'm very fortunate that we are again organizing the third edition of the conference in 2022. We are really very much happy with the responses from all over the world and pan-India. Not only the doctoral students, postgraduate students, but we are very much fortunate that undergraduate students are also presenting their work for this particular conference. Friends, Department of Mechanical Engineering of Sandeep Institute of Engineering and Management is full of highly dynamic and enthusiastic faculty members, and they are doing great under the leadership of Dr. Anil Dubey sir. Now let me tell about Sandeep Group. Sandeep Foundations was established in year 2005 under the dynamic leadership of our Honorable Chairman, Dr. Sandeep Kumar Jha sir, and we have started our first college in collaboration, in association with Savitribai Phule University in 2008, that is Sandeep Institute of Technology and Research Center. In 2009, we come up with our Polytechnic College, that is Sandeep Polytechnic. And in 2010, one more engineering college is added to the Sandeep Group, that is Sandeep Institute of Engineering Management, which again have an affiliation with Savitribai Phule University. In 2011, we have started with Pharmacy Institute, Sandeep Institute of Pharmaceutical Research, where we are offering Bachelor of Pharmacy, Diploma in Pharmacy, and Master of Pharmacy. At present, in the Nashik campus, we are having two engineering colleges, one pharmacy college, and one polytechnic, having affiliation with their separate state universities and state boards. We also spread our wings in 2016, and we are fortunate to get the status of private university in 2016, and ours is the first university in the North Maharashtra region to get the status of private university by government of Maharashtra. And in 2016, we come up with our own Sandeep University, which is a self-financed private university. And at present, in Sandeep University Nashik campus, we are running 7 different schools, like School of Engineering and Technology, School of Computer Sciences, School of Law, School of Fashion Design and Hospitality, School of Science, School of Management, School of Pharmacy, etc. Total student strength in the campus is more than 12,000, and more than 3,000 faculty members are here in the campus, out of which we are also having an excellent hostel facility, and more than 4,000 students are staying in our hostels. We do have one more campus in the hometown of our Honorable Chairman, that is at Sizol, District Madhubani, Bihar. And in Sizol campus, we have Sandeep University, and under that, again, we are running professional and traditional courses in engineering, technology, management, science, and arts. So this is all about the group of Sandeep Foundation. Once again, I congratulate all of the participants for participating in this conference and publishing their work, and wish all the best to one and all. Thank you very much.
Thank you so much, sir, for giving your valuable speech. Thank you, sir. Now I would like to welcome our keynote speaker, Dr. Nilaj Deshmukh, sir, Dean and Head of Mechanical Engineering Department from C. Rogers Institute of Technology, Vashi, Maharashtra, India. Dr. Nilaj Deshmukh, sir, is experienced Dean and Head of Mechanical Engineering Department with a demonstrated history of working in the higher technical education. Skilled in NI, LabVIEW, and experimental setup, strong education professional with a Doctor of Philosophy, focused in Combustion Instability from Indian Institute of Technology, Bombay. Fellow member of the Institution of the Engineers, fellow member of Council of Vibration, and member of FMFP. He has completed 20 years in FRC Rogers Institute of Technology, Vashi. Joined as a lecturer on 1st July 2002, and promoted as a senior lecturer, assistant professor, associate professor, and he has experience in new product development and data conveyor. Dr. Nilaj Deshmukh, sir, is a well-known and recognized authority in the domain of theory and the application of mechanical engineering. I welcome you, sir, to deliver the keynote speech. Please, sir.
Yeah,
Welcome.
thank you, Dia. Thank you, sir. Thank you, Patel, sir.
Welcome, sir.
Yeah, thanks. Are you able to hear me?
Yes, sir.
Yes, sir. Yes, sir.
I will just share my screen first, and then I will start. Can you see my screen?
Yes, sir.
Yes, sir. Yes, sir.
Thank you. Thanks for confirming. First of all, I would like to congratulate Sandeep Foundations and members of IFERP for coming up forward and organizing such a interdisciplinary conference where the researchers and postgraduate students and UG students will take a part. And next 2 days there will be the agenda and variety of talks are there where people will talk about their research work, their projects works, and other activities. Now here you all know that this pandemic, COVID-19 pandemic taught us many things, new things, and as a part of that, we are meeting from different parts of the country, different parts of the world on one platform, that is Zoom now, right? So with this one, I first would like to congratulate to all of you for successfully organizing such conference, international conference, and hope that will continue in future. Here, when you talked about any research activity, most important part is identifying that research topic, research gap, and continuing that research. And I know there are many researchers are here, those listening to this presentation. Here, key task is what? Based during the continuation of this PhD work, research work, or the work if you are doing as a master's project work, during that work, you will face different challenges. How to overcome that challenges, that is a key task. Now, as of my talk as a keynote speaker, I will first I will here try to elaborate my area of research, that is the thermoacoustics. So here I will talk about the thermoacoustic instability and its control. So here when you talk about the combustion instability or thermoacoustic instability, the word comes thermoacoustics. So here thermoacoustics, nothing but what? Generation of sound with heat addition or extraction. If you talk about as and when we are adding the heat or we are extracting the heat, we'll find that some sort of acoustics will be developed inside the combustor or any power producing device, and that term will be called it as a thermoacoustics. So this is a part of the combustion, but many people, those who are already working in mechanical field, might not knowing what is this thermoacoustics, what is combustion instability, and why it is occurring, and how to control that. So I will try to highlight these things in my presentation. So here, firstly, the thermoacoustics or combustion instability. This phenomenon was observed firstly by Rijke in 1859. Right. So here he just found that if we take any vertical tube, and in that vertical tube, if we place any heat source, place any heat source, let's take an example of electric heater. If we place this electric heater as a heat source at say L/4 location, then due to that heating of that coil, and air is coming in contact with that and start moving up. So when air is moving due to that natural convections, or we can say due to the buoyancy, so some sort of sound is developed inside this tube. Some sort of the sound is developed inside this tube. Now, when you talk, at any moment, if you find that I'm not able to hear or my screen is not seen to you, just inform me. Now, if we talk about when this phenomenon is happening, how that pressure fluctuations and unsteady state heat release or velocity fluctuation takes place. Now, if we plot that, you can see here the green lines indicate the pressure fluctuation. The green line indicate the pressure fluctuations, whereas red lines are indicating the velocity fluctuation or unsteady heat fluctuation. Now, if you see this variation, you can see that at L/4 location, you can find out that are coupled. It means the pressure fluctuations and unsteady heat release get coupled at these locations L/4, right? So that is a major cause of developing the thermoacoustic instability. Now, further in 1878, Lord Rayleigh has given a theory why the thermoacoustic instability is happening. So he said that if heat is given to air at a moment of greatest condensations or taken from it at a moment of greatest rarefactions, vibration is encouraged. So whenever there is an acoustic developed inside the combustor or inside the tube, due to that acoustic wave, the vibration will takes place. And that is what it's a feedback process is responsible to occur this thermoacoustic instability. Now let's take just see this diagram where the pressure, there is a coupling between the pressure fluctuations and unsteady state heat release, that is P dash Q dash, and that will lead to the acoustic oscillations inside the combustor or inside the tube. Due to this oscillation, when the oscillation takes place, that will be responsible to create the perturbations in the flow. So perturbations in the flow of air, perturbations in the flow of fuel, and that will be lead to the coupling of pressure fluctuation and unsteady release. So this process will be continued, and this will take a feedback, and that will be grow inside the combustor. So he has proposed try to present in the form of integral that is given as a relay index. So what is this relay index? Is given by 1 by T integral of P dash Q dash dt. So whenever the cyclic, when this integration is greater than 0, it indicates that the occurrence of instability is there inside the combustion. Now, when we talk about this combustion instability, there are n number of parameters which are responsible to occur this instability. Let's take a first example. One is the position of heat source. Positions of heat source, which is responsible to trigger the instability. And when this instability occurs, there will be the different modes of instability. So first mode, second mode, third mode, fourth mode, fifth mode. So n number of modes of instabilities are possible. So based on the burner position or based on the heater positions, the different modes of instability may occur inside the combustor. So here, let's take an example. The first mode, if we talk about, when the burner position is or heat source position is from 0 to L by 2, there is a unstable mode, that is the first mode of instability. Second mode will be occur first part and third part of the tube. Third mode will be occur in the first part, third part, and fifth part. And fourth mode will be what? First part, third part, fifth part, sixth part, so on. We can continue. So we know that, and for any mode, when it is the instability takes place, this mode will have the two basic parameters. One is a node point, another is an anti-node point. So if we talk about the mode 1, the two node point are there. So you can see this is a one node point, this is another node point, two node point, and one anti-node point. Whereas when you talk about the second mode of instability, there are three node points and there are 1 and 2 anti-node points. So similarly, you can find out for different mode the number of node point and number of anti-node point goes on increasing. Now, so when this instability occurs, when this combustion instability or thermocoustic instability occurs in any power producing device, so there are detrimental effects of that. So first we can see that enhance the heat loss from the combustor wall. So you know that all power producing device, we are burning the fuel in the presence of air. Then due to that burning, obviously there will be the heat release. And due to that heat, when heat release, and in that heat release zone, let's consider the instability is present. Means the waves, standing wave or sound wave is developed inside the combustor. So that sound wave will try to propagate the heat or take out the heat from the combustor inside to the combustor wall or inlet and outlet end of the combustor. So that will enhance your heat transfer. Then deterioration of combustion efficiency. Sometimes due to this, if the instability is very strong, that will be responsible for blowing of the flame. So flame will get blow off. So due to that flame is blow off, obviously your combustions will not take place and that will be hampering the combustion efficiency. Then increase in emissions. Basically, if you with this thermocoustic instability, when people realize major impact of the thermocoustic instability in 1990 or 1985 around. During that period, what happened? All at a place of globally, you can say that people were talked about the lean combustion. Lean combustion means quantity of air is more and quantity of fuel is less compared to the air. And people talked about to enhance the combustion instability, to get a more economical combustor, people start thinking about the lean combustion. And when that when the US industries, they start developing the combustor of gas turbine or jet engine, based on this concept of lean combustion, they observe that the nitric acid rain happens during that period, and that was a major part was responsible for what? When this lean mixture combustor is in that, when the instability takes place, the emission increases. Obviously, when you are taking the large quantity of air, percentage of availability of nitrogen will be more, and when this nitrogen is reacting further with the oxygen, NOx will form, and that NOx is responsible when it will form at a larger quantity, and when it will come out as what? The nitric rain. Again, if we are not able to burn completely, then there will be unburned hydrocarbon. If the flame blows off, your fuel you are injecting, so that fuel will come out of the combustor without producing any combustion. So unburned hydrocarbons also increases. Then, when you talk about this instability or this acoustic wave, when it will be there for a longer duration in the combustor, that will be responsible for a structural damage. So, and the health issues. So you can see here, I've given a 3 different photographs. One is a part of a gas turbine or jet engine. Here you can see the crack is developed over that. So that is due to the thermocoustic instability. There is a part of the combustor is broken due to this instability. And when this, you know that the human air up to 80 dB or 85 dB, we can hear the things, we can tolerate that kind of the sound. But if the intensity of noise or acoustics increases more than 85 decibels, we can't tolerate it, right? So here, and if any person is working in that such a noisy climate, his or her ears will get damaged. So health issues will also be occurs due to this instability. So these are the effects. So it's very much essential to control this instability. So when we talked about how we can control the instability, as I said, major drawbacks people found in 1980s or 85. So people start developing the techniques, and at present we can classify the techniques in 2 categories. One is called as a passive techniques and another is called as active techniques. So if you are doing any kind of the certain change in a design parameters of the combustor or a combustion system, that will become as a passive device. Device. And in case of passive device, there are a variety of devices people have already implemented. One is called as a baffle, then Helmholtz resonator, acoustic liner, positions of fuel injection, modification in the fuel injection system. So n number of parameters people varied, tried and got a success in controlling the instability. So at design stage itself, I can design a suitable method based on my requirement, and we can control this thermoacoustic instability. Now, the second here is active control, where we are modify the system dynamics using some sort of external energy. Here we are not using any kind of energy. We are trying to eliminate this instability at the design stage. Whereas this active control, here we are trying to modify the system dynamics based on some external energy. So we are using some energy to control the instability. So there are the 2 methods. One is called as open loop air injections or open loop control system, and second one is a closed loop. You know that closed loop means what? Some kind of the feedback will be taken. And in case of the open, there is no feedback. Is on and off system. So in this case, open loop also 2 different categories. One is what? Air injections, and air injection axially and air injection radially. Again, in closed loop, we are taking the feedback, so the requirement of the actuator is there, and there can be a possible what fuel and air injections, phase shifts. So n number of methods are also available in a closed loop. Now, these are, I have given you a brief idea about what kind of the control systems we can use. So whenever we are targeting, whenever we are designing, or whenever we are selecting any kind of the technique which will control the instability. So firstly, what is the requirement, in which system we are trying to implement that technique? That is very much important to study, and based on your requirement, we can design a suitable control method to suppress or to control the thermocoustic instability. Now let's take different possible applications or possible areas where, in which this control of instability is important. Let's take an example of gas turbine. So you know that as a mechanical engineer, or as this conference is interdisciplinary, people are from the different groups also. So we know that in gas turbines there is a compressor, there is a combustion chamber, then turbines, and then the exhaust system. So this is a combustion chamber where actual combustion is taking place. So if I know the system parameters, and if I know what kind of the mode is of instability is taking place, I can select the appropriate control methods that I can design and implement this system. Then we know that the steam boiler we're using to produce the steam. So when we are converting the water into the steam, obviously we require some sort of the device or combustion system. So let's say this is the combustion systems we are using, and so there also I can find out the sometime if the pressure fluctuations and unsteady state heat will get coupled in a combustion chamber, then in that case again you will find out some sort of the noise you are getting. Then if you take about example of the jet engine, again jet engine also, because these are the power producing device, and everywhere the combustion chamber will be there, and in the combustion chamber we are using some sort of the fuel and appropriate amount of air for complete combustions of that fuel. And when it get coupled, it will instability is taking place. So this is what the jet engine. Sometimes the afterburners, after producing, after getting the useful work out of that gases, we can further pass that gases in the afterburner, and sometimes we may observe instability is taking place in the afterburner zone also. There also I can design a Helmholtz resonator, I can use a perforated liner to control the instability. So there are a number of applications where I can study what kind of the instability is taking place, and based on that I can select the appropriate method to control the instability. Now just I have here given few examples of passive control techniques. So passive control, as I said earlier, it's a baffle. I can use different types of baffles, and Kulik in 1981 he suggested a different baffles and for controlling the different mode of instabilities. Then I can design my combustor using the acoustic liner, using the perforated sheets or a perforated cylinder. I can place inside the combustor, which will be control the instabilities. Then people have used a Helmholtz resonator based on the requirement. I know which mode of instability I need to control. Based on that, I can calculate the volume requirement of the Helmholtz resonator, and we can install that Helmholtz resonator on the combustion system so that it will control the instabilities. Then, in case of active method, first method is open loop axial air or fuel injection. So here, this is one of the combustor people have used for their research work. So here, actually the air and fuel is coming through the fuel injectors and the air injectors. You can see the top view of that. And there were primary fuel nozzles, secondary nozzles people have used. And this active method, people have used this open loop control system, but there is not a complete suppression of instability. So when the instability is taking place, you may observe there is a certain rise in the pressure. There is a certain rise in the pressure. Now here you can see from this graph around 250 hertz or 240 hertz, you will find out the peak is taking place. So that peak considered to be as due to this instability. When this earlier Hume and Acharya, they studied this axial open loop system, they found that there is a marginal decrease in instability, but they were not completely suppress the instabilities. Then, so here again also you can see that overall sound pressure level reduction. So here baseline, you can see the supply of the fuel and air and equivalence ratio. So when we supply the fuel, obviously your equivalence ratio goes on increasing. Now, next method is the open loop method, where the radial microjet people have used in before entering the air and fuel inside the combustor. So in their inlet passage itself, they have tried to inject the air and fuel in appropriate form, and around 17 dB, that much sound pressure level people have able to suppress the instability. Then in case of the closed loop, different researchers tried what the phase shifts. So if I'm taking the feedback from the microphone, then that acoustics waves, the phase shift can be there, then you can amplify it, and then that amplified sound can be given to the loudspeaker, and then loudspeaker again it will blow on the another sound wave in opposite direction. So one wave is coming from left to right and another wave coming from right to left, and that will be what cancelling the instability or controlling the instability. Then fuel injection. So people try to inject the fuel at the inlet passage. So what drawback of this method was what, which was lead to what, increase in a equivalence ratio. Now, whenever you are identifying your research gap, firstly that you need to carry out the detailed literature survey, and from the literature survey we are trying to what is the motivations to carry out that particular research activities. Now here, because as a researcher we need to study more than 100 papers which are very close to your work, and from that 150 papers we need to conclude the things, and based on that we can identify our research gap. Now here, what is the motivations to carry out this work is what the passive control techniques, if you see, which are designed for a specific operating condition, and that will be as it is operated for designed for a specific operating condition, the controlling parameter is limited. And all this combustor, if you talk about the jet engine or a gas turbine, the loading condition is very dynamic. So if you design any technique method for controlling the passive method, that will suppress that particular mode. But during the actual operation, if the another mode triggers, that technique may not be able to control the instability. So that is what I have written here. The control is limited. Then the second one is what, open loop air injection. If you have seen in literature, it's a easy here directly aimed at the plane of heat release. In earlier studies, they have not considered this air injection in the plane of heat release. They have considered before the combustion taking place, they have injected this air, and that is what in the axial as well as radial form. Then third is what, the closed method. So closed loop method required expensive and complicated actuator because to take the feedback. So reliable sensors are required. So with this one, when I'm doing this my work, when I did my work this IIT, and now I'm continuing that work, but with latest literature reviews and based on the latest trend, we are always modifying these motivations and the aim. So aim was to develop, suppress the thermoacoustic instability using the radial microjet as a open loop active control to develop the pressure to decouple the pressure fluctuation and uncertain heat release at the plane of heat release following the relay criteria. So here, to achieve that kind of the aim, we have developed the experimental setup. So here we are consider a one tube, one dimensional combustor. So when we are considering the L by D ratio, when L by D ratio is greater than 10, L by D ratio is greater than 10, then I can consider that as one dimensional combustor, which will be easy to analyze. Then we use LPG and air as a pre-mixture, and we are using the traverse, we are able to transfer or move the burner inside the combustor. Then we use the plenum chamber, then different instrumentation were used to measure the flow rate of LPG, flow rate of air, pressure fluctuation, to measure pressure fluctuations, pressure sensors. Then for measuring the luminance, TV luminance of this one preemptive tube, so different instruments were used. So this is a photographs of experimental setup, where you can see that the combustion chamber using the acrylic tube we have studied to get the chemiluminescence of the flame, and we are because whenever we are thinking to develop the system for very complicated one, firstly we need to make a prototype, we need to develop the model based on your whatever the techniques we are proposing or suggesting. So based on that, we come up with a simple technique. Just we have considered we took a burner, a pre-mixed burner, and we took one copper ring, and on that copper ring we drilled a hole of 1 mm, through which we tried to inject the air in the form of microjets. So here from this diagram will be clear. So here when the burner is from the burner, when the LPG and air is taking place, and when the flame is there, so this radial microjet will become in direct contact with this flame, and it will able to decouple the coupling between the pressure fluctuation and heat release. Now, initially, firstly, from the combustor, I need to analyze what kind of the mode is taking place. Now, if we consider there is no instability, this is a frequency spectra. This is a frequency versus sound pressure level, frequency versus sound pressure level. I can get that spectra, and from the spectra, I can find out that for lower frequency also the sound level is not more than 60 dB, around 60 dB. And when the instability took place, you can see that there is a rise in this peak amplitude of the sound pressure level, SPL. So it is around 100 dB and up to 60 hertz, which is a first mode. Then if you go for second mode, you can find out 90 dB and 512 hertz. Third mode, 88 dB and 780 hertz. So different modes is possible by different. If I'm varying the heat source, I can generate a different mode of instabilities, and based on that, we can get the photographs of or images from the high-speed cameras, and we can analyze further for as a research activity to get the what is exactly happening at a microscopic level. Now, when you talk about the flame mode 1, you can find that the long flame due to the burning of large air and fuel, large quantity of air and fuel. So flame length is larger, that's around 150 mm. When it is second mode is taking place, little bit lesser quantity of fuel and air. So flame length is reduced little bit to 120 mm. When the third mode is taking place, you can see the further reduction in the. So flow quantity is very much important when we are talking about the instability is taking place. So to controlling the instability, major focus should be on what? Flow of air and flow of fuel should be appropriate so that instability does not take place. Now there are different parameters when we are carrying out a research, different parameters we need to measure, and based on that measurement, we can prove whatever we are claiming it is correct or not, whether we are getting that results or not. So n number of parameters based on which we can judge the system is effective or not. Now, here hypothesis we have proposed that when we are injecting this micro jet inside the combustor in the vicinity of the flame, we have assumed that we have considered that initial phase there will be an increase in a heat content, So then if I'm proposing that hypothesis, I need to prove that. And while this measuring this temperature, unsteady state heat release during the combustion, that is the key challenge. So what we did, we come up with what simple method, because when you are doing the research, as I said earlier, you need to face the n number of challenges. How you are overcoming the challenges, that is the key task. So we thought, we discussed multiple times, and then we come up with what the one simple method. So we use a thin thermocouple of 1 mm diameter at different locations. You can see this from this photograph, at different locations, of this one-dimensional combustion. So 1, 2, 3, 4, 5, 6, 7. 7 thermocouples we have used. Right? And inside that LPG and air burner is there, so continuous combustion is taking place, and air is sucking by the suction pump. So air is in the presence of fuel. So we are trying to mimic the same conditions, whatever is taking place at the gas turbine combustor or a jet engine combustor. Now, so we took this thermocouple of larger probe length, and then what we did, our aim is to what? Let's say if I take a cross sections of this one-dimensional combustor, I will get this circle. I will get a circle. Now, in that circular circle, I can measure the temperature at different locations. So I can traverse this thermocouple in vertical directions, right? So let's say if I took this diameter of this combustor is 80 millimeter, I can, in a step of 5 millimeter, I can traverse this one, and I can get a different 9 locations from the center. And then for a second one, I can rotate this one-dimensional combustor by 15 degree. I can rotate this combustor by 15 degree. So if I do this exercise for one single plane, I am getting the measurement of 193 location. I can measure the temperature, and if I know the temp, and again surrounded to that particular temperature where we are measuring, we are considering the constant amount of heat. So from that, I can calculate the mass flow rate in an individual zone, and if I take a summations of all these zones, I can calculate the heat content in a particular plane. So this is a real challenge when you're doing the research. So just imagine for one plane, 193. Similar, at the same time, I can traverse the other thermocouple at the other plane, rotate the combustion every time by 15 degree. So 24 times I can take the measurement for the rotation, and 9 times for traversing, moving the thermocouple inside the combustor. So I can get the measurement at 193 location. And if you are using any kind of LabVIEW or any other interfacing software, and if you are connecting the thermocouple with the appropriate hardware, you can get all these reading in your system, and you can post process. Now we have found out the temperature in one plane, and from that we can able to plot the temperature map. So these are not, people may think that these are the simulation results. No, my dear, all these are our experimental results. We have plotted whatever the data we got during our measurement at different 7 planes, as I said earlier, And based on that, when we consider there is a instability is taking place, when there is a control system is not working, you can find out nearer to, this is what the nearer to the burner plane, and away, this is last one is what away from the burner. So when we are going away from the burner, you can find out there is a decrease in a heat content, and this is the last plane where we are carried out the measurement. Now here you can find out when there is a no control techniques, you can find out there is a some zone where heat is concentrated. But when we are injected the air in the form of radial microjet, you can find out this hot spot got diffused and heat is uniformly spread in an entire plane. And you can find out compared to the earlier, you can see in all plane, if you calculate the heat content in each plane without control techniques, you can find out when the control technique is on, larger amount of heat is developed or heat is produced. And that way I can say that this radial microjets help me to increase the combustion efficiency. So that way we need to prove when we are carrying out any kind of the work. Now people may ask that, yeah, now you tried these techniques for the one particular case, it may or may not work for the another case. So that's why here we are considering equivalence ratio as a 1. So based on the air fuel ratio, I can get a different equivalence ratio. So we can try out different equivalence ratios. So let's say equivalence ratio is 0.8. So again, for that case also, compared to the control off, you can find out in control on conditions, you find out a more heat content in every plane. Then we tried for a lean combustion, that is a 0.65. There also we can find out it is naturally stable and more heat content was there in every plane of the combustor. And then we can plot the graphs for different equivalence ratio for different heat inputs along the axial directions of the combustor, and you can find out with control technique, with appropriate method, we are able to increase the heat content by 10 to 20% increase in a heat content. So that was our achievement. So why I'm showing these graphs to you, so that whenever we are proposing any kind of the hypothesis, we need to prove that whether it is feasible or not. Then next challenge was for getting the heat content at all the point. So then we have come up with what the measurement of the chemiluminance. So here, based on the measurement of the chemiluminance, I can consider that in that flame or while the combustion is taking place, the heat release rate or heat release fluctuations I can predict, and if I analyze that further using the pressure fluctuation, so I can predict whether the coupling is taking place or not. If the coupling is there, it means that instability is taking place. So we use PC with the data acquisition systems. We connected that to the bus spectrum analyzer. From there, we got a higher voltage. The high voltage and currents were given to the photomultiplier tubes, and from the photomultiplier tubes, we have measured the chemiluminance. So larger the slope of the chemiluminance, intensity, I can get that the larger the equivalence ratio. So that study was proposed, and then with the control techniques, you can see that if I measure the pressure in the plane of combustion, if I measure pressure at the plane of combustion, so you can find out when the instability is taking place. Around 20 Pascal pressure was there, and acoustic pressure, particularly this one, not a flow pressure. This is acoustic pressure, and when we use when we switch off the control, when we switch off the switch on the control techniques, switch on the control technique, here you can find out the pressure is gradually decreased. Pressure is gradually decreased, and that will become around 1 to 2 Pascal. So, and for particular cases it reduced to 18 to 4 Pascal. You can see from this graph. So from that, and we know that for calculating the sound pressure level, we are using 10 log of P by P reference bracket square. So here, if your pressure is 18 Pascal, 18 Pascal is corresponding to around 100 dB, and 100 dB sound human being can't tolerate. This is, I'm talking about the one-dimensional combustor in a laboratory scale. But if you talk about the combustor of the jet engine or a gas turbine, you may find the amplitude of this instability may be around 200 dB, right? So that 200 dB will create different problems in a combustor. As I said earlier, the combustor may get damaged, structural vibrations, cracks will be propagated. Now, so here you can see that can be proved now from the frequency spectra. Now, this is a peak. This is the pressure. You can see that this is when the instability is taking place. Whether after the control technique, this is your background noise. This is a background noise. If I'm able to capture the background noise, which when I'm carrying out my experiment during the in the lab, that time what was the sound level? So background noise and when your system, when the control technique is on, it is almost same. It means that the technique which we have developed to control the instability, the sound pressure level reduces to the background noise. And in literature, we found that people were able to suppress the one mode, but they were, due to that some modification in the system, they observed the secondary peaks was there. But in our study with our techniques, we found that there were no rise in a secondary peak. So that also we need to prove from the data, and we need to analyze the data, and based on the data, I can claim whatever we have proposed as a hypothesis, whether we have succeeded to achieve that or not. Now, so here people have given or released in 1890, he has given that integral, that interpower relay index. So then we have come up with how I can characterize this instability. We propose the coefficient of relay index, CRI, we have proposed from our study. So I'm getting the instability at P dash X dash at any burner positions as well at any time. I can get the maximum amplitude of the pressure fluctuation, maximum amplitude of the heat release, and if it is greater than that, integral is greater than 0, I can say that instability is taking place. So we can get a different phase angle between these two waves, that is the pressure fluctuation and the unsteady heat release. So from that, I can consider that when the phi is less than 90 degree, when the phi is less than 90 degree, when phi is equal to 5 degree, here this curve is for 5 degree, there is a strong coupling between the pressure fluctuation and unsteady release, and you can find out CRI is around 0.49. But when this phase angle between these two waves are 90 degree, you can find out CRI is 0. Similarly, when it is greater than 0, for 95 CRI is negative, for 180 degrees CRI is negative, but it's a minus 0.5. So what we can conclude here, when these two waves are close to each other, then the strong instability will occur. So from that, we carried out a different experiment. We measure the pressure fluctuations, we measure the unsteady heat release using the photomultiplier tube, And from that from what results we got for, let's say, equivalence ratio 1. So we found that there is a strong couplings, and we found that CRI is around 0.49. And when we use the control techniques, you can see that the large amplitude was there, around the 1. Here you can see that it's coming to 0.04 or 0.05. So here with the control techniques, the CRI was, you can see that 301 into 10 to the power minus 6. So very low CRI we got. So it means that the measurement which we carried out, so whatever the fundamentals was proposed, which is supporting the things, and accordingly we got the results, and that was proved for different equivalence ratio also. We got the same kind of the trend. So it means that the measurement which we carried out for our unsteady heat release and pressure fluctuation, that is fulfilling our requirement. Then similarly for different equivalence ratio 0.85 or 0.8, so we got different trend, and then we can compare that coefficient of relay index for different phase angle. Now, when the control technique was off, when we are not using any kind of control techniques, we can find out the CRI, the coefficient of relay index, was larger, was very large. And when the control techniques we are used for all these equivalence ratio, for all these phase angle, all these phase angle, you can see it's very close to zero, and it's very close to 0. So it means that control technique is very much effective. So here I need to prove the same concept by different measurement. Then third type of the parameters which we have measured, we have taken the flame photographs, and from flame photographs we got the coefficient of relay index for different equivalence ratio. This is oblique view of all the flames. This is the side view of the flames. So you can see that when the control technique was on, you can find out the larger flame length compared to when the control technique is on, and there is a color change in the blue which indicate that the more amount of heat is developed when the control techniques is on. So here, based on that discussions, based on the work which we have carried out, we can easily conclude that whatever the setup we have developed, that is very unique, and burner and microjet ring assembly can smoothly traverse inside the combustor of its length. So setup is demonstrating the different modes of heat transfer, modes of thermocoustic instability. We can able to measure the hydrodynamic pressure and acoustic pressure outside the restricted tube, both exhibited occurrence of suppression of instability. Then we are able to control the instability with the background up to the background noise, and it is more than 30 dB. We have come up with what the non-dimensionless CRI for the characterization of whether the instability is taking place or not. And from that we conclude that CRI should be of 0.5 to 0 for when the instability is taking place. So before going ahead, so to get the more idea about whether the instability, to what I can say the instability is there or not, just I want to show you the one video. Then for that, here, if I will show you the video. Can you see the video?
Yes,
Somebody can
sir.
confirm. Are you able to hear the sound?
No, sir. No sound.
Just check it now. Sound is there?
Yeah. Yes, it's audible.
Yeah. Now here I just want to show you that when the instability is taking place, let's say this is the third mode of instability, and we have captured the things from the tube, that video. So here you can see that loud sound. So this type of the sound will be developed inside the combustor. This type of sound will be developed inside the combustor. This is the third mode of instability. Now you can go for a different mode. This was the second mode, and you can see that the flame is lifted. So different as the air and fuel ratio was high, flame got lifted, and we were able to develop the second mode of instability. So different studies we can carry out, and then when we use the control technique, you can see that through the video. In the initial period of the combustion, we have not switched on the control technique, and as you might see that when we use the control technique, when microjets interacting with the flame, it was start reducing the flame length, and it reduces the acoustic level. And again, when you switch off the control technique gradually, you can find out that flame is again coming to its original positions, and instability start developing. So that is the I can say you can use a different control techniques for your work, and based on that we can analyze the data, and we can present the things in different conferences as well as journal publications, or we can patent it. So at present, based on my research works, I have more than 30 papers in the different journals, 50% papers in different conferences. I have 2 patent files in my credit based on these techniques. This is from my side. If any participant want to ask anything, or anybody want to ask anything, session is open for the discussion.
Hello.
Yes, sir.
Hello. Good morning to you, sir.
Yeah, good morning, sir. Good morning.
So first of all, thank you very much for such a good presentation, sir. It is a very elaborative research work you have done, sir. The question is, the instabilities which you mentioned, can these instabilities be used for achieving some better effects on the positive note?
Yeah, that can be thought, but again, the intensity of the instability and what frequency that instability is taking place. So if we are able to find out the applications where these instabilities are required, definitely we can. So for your information only, one of my PhD student is working on what? We are developing the instability, and we are using that for the process equipment cleaning. You might be aware that the process equipment cleaning, acoustic.
Yes, exactly.
We can
exactly, sir.
So one of the students is working in the directions, and we are using this instability for cleaning the process equipment.
Right, sir. Yeah, and is there anything to do with the shape of the combustor, sir? There also Definitely. We can achieve some different effects on the positive side.
Yes.
Thank you very much, sir. Thank you.
Thank you so much, sir, for delivering a wonderful presentation to us. Thank you, sir. Any more questions from the respected participants?
If you don't mind, sir, one more question, sir.
No problem.
So how these images of the flame were obtained?
Oh, using the high-speed camera.
High-speed camera. Okay.
Any more questions from the respected participants? Thank you so much, sir.
Yeah, thank you. Thanks a lot.
Now I would like to welcome our keynote speaker, Mr. Fred Henney, sir, President at Daikin Solutions, Alberta, Canada, to deliver a keynote address. Mr. Fred Henney, sir, is the President of Daikin Solutions, a company which provides innovative solutions to the heavy industrial business sector. He is a recognized leader in developing the most optimum capital efficiency for owners of heavy industrial projects. He has been globally recognized as a subject matter expert for his development of standardized modular design practices and execution solution and lean design and execution. Fred, sir, has over 40 years of experience in heavy industrial project execution. He has executed various phases of heavy industrial projects from front end through detailed engineering, construction to commissioning and startup on a global base. Portfolio assignments include zero-based execution development and subject matter expert for modularization and technical lead on fluoro third generation modular execution SM research and development. He has experience in the role of subject matter expert and provide quality assurance throughout the development phase and through the completion phase to ensure that the overall business and project objectives are being achieved. Welcome, sir.
Thank you. And it's a pleasure for me to be here at the 2022 International Conference on Emerging Trends in Technology. I'm going to share my screen now.
Yes, sir.
So just let me, just hold on here. I hope everybody can see my screen.
Yes, sir. Yes, sir. It's visible.
So it's, like I say, a pleasure to be here, and I thank the organizers for inviting me for this keynote speech. I am going to be talking about something a little different than the previous keynote speaker. It's going to be more on the practice once you as an engineer, whether you're a mechanical engineer, electrical, or civil, or structural, or automation, on what to expect in the industry, particularly if you move into the heavy industrial sector that is in a global basis these days, and where the industry is going. And what I want to talk about is productization and how to embrace industrial productization. Okay, that's my keynote speech is going to be about. I'm expecting that you should learn aspects of what to expect once you get out into the industry, and what you need to be prepared for, and as well what you may need to be look for as far as education to help you get there when you move into this area. So you've already heard what I am, and I don't need to go through that. But what I'm going to talk about is industrial productization, something that is going to be new. It's in a certain case novel to the heavy industrial sector, but you may have heard it in other sectors that outside this area. And besides explain what it is, I want to also why you should embrace productization. I want to go through that with you. And then something that is, I'm sure everybody's heard of in the past is the importance of ESG, environmental sustainability and governance. Something that is you will be expected to know when you get into the industry, and it's playing a much larger part into the engineering and design of facilities. And then what do you need to do to implement productization? So I want to go through these subjects and help you understand what the changes are going to be in the next decade that you need to be prepared for. Just so everybody understands, when I mean industrial facilities and design and engineering of these, I'm talking about major facilities such as power plants, refineries, chemical plants, gas and LNG plants, nuclear plants, mineral processing plants, the heavy industrial sector, which is really what I'm focusing on. Although what I'm going to talk about applies to other industries as well, light industrial and commercial. They may be more advanced in this area than the heavy industrial sector. So what is productization? Well, if you really take a look at what productization and how it can be defined, it's been documented. It's a process of analyzing a need, defining suitable elements, putting it into a product-like object, and then you standardize it, you repeat it, and it's very comprehensible in what you're delivering. So it is a product. You end up providing a product. When we look at industrial productization, it's the process of designing and building a facility which can be replicated for all other similar types of facilities, and it applies fundamentals such as lean, sustainable design, and execution with standardized units. So it's a very repeatable area. So that's what you need to understand when you look at this. It's a different and a novel strategy that's being implemented. It's different than the traditional methods that you may still experience when you get into and get out and get into the practice in the practical world. So why do we want to implement productization in this market? And I can tell you that there's a tremendous amount of demand by owners to take a look at their return on investments, and the traditional methods that have been applied over the last several decades have not provided those return on investments that they need. And of course, when you get into the practical world, part of what you do is to assure at the end of the day that the service you're providing provides a return on investment that's acceptable to whoever's asking you to do the work. And I can tell you over the last couple of decades, there's been a significant number of industrial projects that have not met those expectations. So industrial productization is going to help you achieve those requirements. It reduces the risks associated with these traditional executed projects, and particularly very large projects that may be executed, and as I see it in the future, there'll be less of these mega projects and more of these productized projects where you can replicate them. Okay, productization improves your safety and quality, a key element, and what are measured by owners that are looking for these services, and it produces and it can help companies such as engineering, procurement, and construction companies of whatever to build more tangible and intangible assets in their operations. So it's a real key success factor for EPC companies to be successful in the future. And those companies that embrace this are going to be more successful than companies that struggle to achieve productization in their services. Another key element of productization that is being considered, particularly by investors, is the ability to contribute to the ESG, or environmental, sustainability, and governance, and support those type of strategies that investors are looking for these days. So productization provides that enhancement that will be needed. Now, if I take a look at embracing and why I embrace it, you'll find that, as I said, productization lowers the risk of executing these type of projects, and it lowers the risks, and it allows smaller complexes to be built at a more predictable and cost-effective, both on cost and schedule predictability, and they can be replicated. So if you can imagine, if I have a very large processing facility, and it takes me 4 years to complete it, from engineering to starting these facilities up, and these are heavy industrial type facilities. If I can standardize it and replicate them, but make them smaller, I could probably complete a smaller productized project within 2 years, and I can then put another one up in another year and a half, another one in a year and a half. It improves the cash flow, as well as it gives you a surety on exactly what you're doing. This is really where the future is going. And you need to be prepared for it, because it takes a different strategy and design method that is different than currently being executed out there. As engineers and designers, we like to customize. And when we customize, every plant is different. In this case, you need to learn to standardize and have the ability to standardize facilities with different inputs and outputs in order to be able to come up with a product that can be repeated. Now, I did emphasize the fact that investors themselves are now more prone to look at projects and the future projects that are more supportive of environmental, the ESG component, environmental, social, and governance type criteria. So in order to do this, the productization definitely improves and provides significant benefits on particularly environmental sustainability aspects of a overall executed life cycle of a project from beginning to end. So if you're not familiar with the term ESG and sustainability, you will need to, and you will need to understand what are the governing factors and what are the measurements that are going to be put into determining if you meet these goals. The global environment, and when it comes to ESG and the criteria, is still being developed, but you need to be prepared to get on board with what these requirements are. And the reason I'm saying this is most companies now have this sustainability requirement in any of their investments, investors will look at an ESG score to see if the actual project moves in the right direction to support these policies. And traditional methods are not going to survive compared to productization. Okay, so if I take a look throughout the life cycle of a project, it's going to start at the beginning, but you're going to find out that, you know, with smart engineering, when I say smart engineering, it involves, you know, more than somebody being smart, a smart engineer. It requires elements of how you do the smart engineering through, for example, which I'll talk about in a minute, digital data and how you manage it throughout the life cycle. But it will, by applying these strategies of standardization and modularization and lean design, you will definitely reduce the overall carbon footprint through the life cycle of the program of projects. I always talk about programs now because you're doing more than one project. And that's the way owners will look at it now. They'll look at a program and how they can replicate these. And by doing this effectively, you're definitely supporting sustainability throughout it. Right now, for example, construction industry, about a third of all the materials are thrown away, contributing to 40% of the solid waste in our landfills. Believe it or not, these type of statistics are out there. And productization will significantly reduce this waste. It gets into applying sustainability throughout it. You'll find that digitally driven productization, I mentioned the digital side of it, will reduce overall effort and rework if it's applied properly. Productization will provide a safer execution, which is a more social responsible strategy. So these are elements that are going to move you in this direction. Now, when you implement it, you're going to, and I've talked about this in previous conferences, you need to design, you're going to have a design for the manufacturing and assembly approach. It's a different method. It's like, for all intents purposes, designing a jet engine, like what we heard before, except the jet engine, which you can standardize and you will optimize all the design elements, including what is required, for example, for noise abatement, like what we've heard. But once you've optimized and designed it once, you'll repeat it. You never customize jet engines, for example, you will repeat them. Well, you need to take that thinking to an entire facility, because that's where we're headed. Okay, so you need to, just a sec here. You need to collaborate during the execution in order to get this. Now, this is something that's really different and is a struggle for most teams that try to implement a productized execution. And that's being able to collaborate amongst all players. That means the mechanical engineer needs to collaborate with the electrical engineer. And this requires some thinking, and some, once you get out into the industry, some of the companies may struggle to get into this type of execution. So to me, there's needs to be on the up and coming engineers and designers out of universities, a learning on what it takes to be able to execute in this manner and design facilities that are standardized and repeatable. Of course, there's excuse me, lots of new digital technologies out there. The digitization of information is going to be critical to make this successful. So you will find that information and information management is going to be a key success factor in making sure that this works. Okay, let's talk about some of the other elements that you need to look at when you're executing a project. You really have to change your mindset. I can assure you most engineers and designers that come out of universities or technical colleges, they're not aware of the fact that your mindset for this type of career focuses more than likely on customization. But you have to change your mindset from customization to standardization. And it gets into stop making things for the first time every time. You'll hear that statement several times in the future. Otherwise, you make it once and then you make it the same way every other time. I do want to say though, when you do a program where you do products and you productize industrial facilities, you'll always take a look at the first one you productize and take the lessons learned from that first one and apply it to the next one and have those improvements in. But from there on, you pretty well have a standard set that's applied throughout. You want to make sure you can standardize by using modular plug and play designs. I always relate this to the industry, the automobile industry, where the automobile industry now is a compilation of modules, and they're plug and play type modules. As they go through the assembly line, components come in, they're all standardized for a certain car line, and they're put together with standard modules. And you need to think in that manner on an industrial facility. And I'm being very sincere here. It is a struggle for some engineers and designers to grapple with the fact that you can standardize your design and not customize it. And there's always, and with the traditional engineers and designers in the field right now, they are currently struggling with this, and they need to move in that direction. What I like to see is the colleges and universities and technology colleges come out and provide some training in this to make sure they're aware on how to do this. You need to engineer lean designs, and that's something that is not taught anywhere. And I wish it was, but lean designs has to do with sustainability and removal of waste. And this is a real struggle with the industry right now on what is a lean design and how do I get there. And it is very important in this aspect. This is where the industry is going to go though. So you need to be aware of that. You need lean execution. Again, it gets into waste. Lean deals with waste, and sustainability wise, it's going to be a key element. Again, in the supply chain and construction, we need to make sure we have sustainable designs in order to go down that route. And we want to make sure we maximize the integration of digital data. And this is something I've mentioned in the past on conferences. Digitization is critical, and the effective use. And when I say the effective use, the cost-effective use of digital data. There is a lot of experience over the last decade, where companies are trying to digitize their data. They do a lot of digitization, but they don't know how to manage the data in order to get what they need out of it. And this is a direction that we need to go into. It's going to be a fundamental key aspect, but we need to make it simple, and we need to make it cost effective. Okay, the fact is, the mindset of the company, they need to change to drive the reusability of data when it comes to digitization. And right now, there's challenges out there. There's some innovative solutions out there, but some of the solutions are very difficult to apply, and we need people that can come and apply these solutions on a more cost-effective and time-friendly environment. Okay, all the processes that we use in the future should be digitized. There's sufficient software out there that is available, and we need to make sure it's the cost-effective solution software. Excuse me. I've actually presented this information before. It's something I feel is very important, and we need to make sure that everybody understands the fact that the heavy industrial sector is becoming more digitized. You've heard of the word digital transformation, and how the digital technology is being used by companies. I think there's a room for growth on simplifying it and making it a little easier to apply. So a key element that I've worked with digital data for a couple of decades is making sure that everything, every record, every element, every component, whether it's engineering information, whether it's scheduling information, whether it's cost information, needs to be digitally recognized and attributed. And it requires a certain amount of knowledge on how to get there. I think one of the elements that I see missing in some of our universities and technical colleges is how to apply this property. There are enterprise systems out there. These are enterprise resource planning type systems, but as I said, they can be very expensive, hard to use, and we need simpler systems that need to be developed. And this is something I think if we could get universities to take a look at, they could provide some very valuable support in this area. So there's lots of digital information and methods out there. The traditional methods are going to be going, even the ones today. The traditional automation and smart instruments and wireless instruments, that's all here today. Asset managements have been around, historians and business systems, all available. But we're going to be looking in the future here for things like the Internet of Things and how that's going to be applied, cloud computing, digital twins. I'm sure you've heard the word digital twins. Sometimes I think it's overused, but it's something that's going to be used. Augmented reality. In my experience over the years, I've used some augmented reality in the past successfully, but there's huge advancements in that area that's going to assist in productization and moving this forward. And of course, cybersecurity is going to be a key element that we need to make sure we address. So to summarize here, we need owners, investors of industrial projects or programs. We want them, and they need to embrace productization, and really they are. You're going to see this is where the industry is going. Be prepared. But as I said, engineering universities and technical colleges need to embrace productization. They need to be able to provide this type of education to individuals coming out so they understand the differences they need to do. And they also have to have this knowledge in order to be able to, I guess, I don't want to say push back, but in some cases, you may run into individuals that are not privy to this type of education, and they will need to get educated. And you need to be able to provide that type of reasoning to them. Okay, so on top of that, contracting, engineering, design, supply chain, and constructors on a global basis need to embrace industrial productization. In the heavy industrial sector, if this doesn't occur, it's going to be a dying sector, and it isn't going to die off, it's just going to happen. So that's really what I wanted to, in my keynote speech, give you this new term that you may have not heard. I really want you to consider it. I want you to take a look at what you have to do on a practical side in order to, any questions?
Thank you so much, sir, for your valuable presentation. Any questions from the participants? Thank you, sir.
Thank you. Let me just get out of here. Okay, if there's no questions, then I'll leave it with you.
Thank you, sir. There will be a small announcement. There will be 10 minutes of break. Within 10 minutes, we'll be joining the technical, we'll be starting the technical session. I request all the participants kindly jot it down. Within 10 minutes, we'll be joining the sessions. Thank you. There is a small announcement to the participants. Breakout rooms are open and respected participants can join their agendas. Thank you. We'll be joining this session within 3 to 4 minutes.
Hello. Hello.
Yes, ma'am.
Yeah. In which breakout room should I join?
One sec, ma'am.
Hi, Bhavana, can you hear me?
Yes.
Yes, you can join the room according to the agenda.
Yeah, I'm a session chair, ma'am, for computer.
Just a minute. You can join technical session 1B.
1B. Okay.
Yes.
I request all the participants, please join the breakout rooms. We'll be starting the session. I'd like to invite Kuldeep Singh Satish Patil sir from presentation on wireless smart electrified road for EV with dynamic and static charging by solar energy. Kuldeep sir, are you present there? थोड़ा उसको बंद करो और I would like to invite Dr. V.S. Ahir sir for session chair of technical session 1A.
Hello. हॅलो सर, एक मिनिट मला इंट्रोडक्शन करायचं आहे ते स्पीकरचं, मग मी करतो.
Good afternoon, everyone. I'd like to welcome Dr. V.S. Ahir, sir, for the session chair for technical session 1A.
Hello.
Hello.
Yeah, good morning, madam.
Good afternoon.
Can I
sir.
introduce Dr. Ahir, sir, please?
Yes, sir. Yes, sir. Please, sir.
Yeah. Good morning, one and all. I welcome you all for the International Conference on Emerging Trends in Engineering and Technology, ICETET 2022. On behalf of Department of Mechanical Engineering, Sandeep Institute of Engineering and Management, in association with IFERP. I would like to introduce the session chair, Dr. Vishnu Sadashira Ahir, sir. Sir is Associate Professor in Mechanical Engineering Department in Amrut Vahini College of Engineering, Sangamner, Maharashtra, India. Sir completed his post-graduation ME in Mechanical Design Engineering and PhD in Design domain only. Ahir, sir is having publication. International papers published are 4, and papers published in reviewed journal, peer-reviewed journals, they count to be 3 nationally and more than 17 international papers. In the conference also, the number goes beyond 13. So I welcome Vishnu Ahir, sir, to listen to the session 1 papers as a session chair and mark the papers as per merit. So thank you very much. You can proceed, ma'am.
Thank you, Chade sir, for introducing me as a session chair for this conference. Thank you.
Yeah, welcome, sir.
Thank you so much, sir. So shall we start? Ahir, sir, with your due permission.
Yes, please, ma'am.
Yes.
You can start the presentations.
Yes, sir. Yes, sir. I would like to invite Kuldeep Singh Satish Patil, sir, for presentation on wireless smart electrified road for EV with dynamic and static charging by solar energy. There is a small announcement for the presenter. There will be 8 minutes of presentation. Kuldeep Singh, sir, are you present there?
Ma'am, he is not in meeting.
Okay. Ahir, sir, can we proceed to the next presenter?
Yes, ma'am. Please proceed for second participant.
Yes, sir. Thank you, sir. I would like to invite Pramod Bharat Diore, sir, for paper presentation on IoT-based smart production line. Pramod, sir, are you present there? Pramod sir. Moving to the next presenter, Danish
Yes.
Raja Abdul sir. Paper on performance evaluation of mini air cooler operating on solar energy. Danish sir, are you present there? Okay. I would like to invite Kiran Sajan Pawar ma'am for paper presentation on design and development of portable bricks machine using natural leaves. Kiran Pawar ma'am, are you present there? Moving to the next presenter, I would like to invite Yash Bhaviskar sir for presentation on effect of aging on performance of ice plant test rig. Yes, sir. Yes, sir. Are you present there? Moving to the next presenter, I would like to invite Ankit Dugai sir for presentation on design and modification of banana fiber extraction machine. Aniket Dugai sir, are you present there? Moving to the next presenter, I would like to invite Professor S.B. Ambarkar on paper presentation on design and fabrication of filament extrusion machine for 3D printer.
Good morning, ma'am. Thank you for giving this opportunity. I am Nishan Sirsat.
Sir, so please share your
Am I audible?
Yes, sir, you are audible.
Yes, ma'am. Yes, ma'am. Is my screen visible?
Not yet, sir.
Just a minute. Is it now visible?
Yes, sir. It has started sharing.
Yeah.
Yes, now it is visible.
Yes. Yes. Basically, we have the idea that the extrusion. Okay. Am I audible? Am I audible? Hello?
Yes, sir. You are audible, but your voice is breaking.
Okay, just a minute. Am I audible now?
Yes, please start your presentation.
Yes, sir. The idea behind this project was nowadays the era is moving towards the 3D printers, sir. For that purpose, we need one filament, which is the plastic filament that will be that will be our product when it is melted and it is turned into the when it is turned into a product. So we have the idea to make that filament at a cheap cost, as this filament available in the market is so expensive. So this is the biography of it. It is the idea which is related to the extrusion, and we have used some extrusion idea, and which is used for various plastic materials like HDP and ABB. This is abstract, and this is the model design, in which you can see a motor. Then there is a clamping. We can say it is a coupling. Then there is a hopper. Inside that there is a barrel in which the screw is mounted. After the on the barrel only, we have the heating element, which will be hitting the material which is poured from the hopper, and then there is a die, and which will extrude the filament, which is about 1.75 mm. And then there is a spool which will wound the filament, which is extruded from the die. And there is some control panels for controlling the temperatures of the heaters. There is a controlling of the flow of the output from the die, so that we can wound it accordingly. And this is stable for clamping all the structure. The screw, it is the screw. Actually, we were about to take some barrel only, but as the market in market there was not availability of it, so we have taken some wood drill to use as an extruder. Then the barrel is just a pipe in which the screw will be inserted, and which will create the force. And this is a barrel. You can see that, and there is one cut made for the hopper section. This is the die from which we can get our output, and this is hopper, and this is the regular wiper motor. As we have to reduce our cost at the minimum level, so we have used this one. These are heaters, heat bands, we can say, which are mounted on the barrel. So our conclusion was that the 3D printer which was used nowadays are so expensive, and our conclusion was we can reduce it by reusing the available plastic wastes. Thank you, sir, and thank you, ma'am.
Thank you so much, sir. Any questions from the respected judges?
Yes, Shirsat.
Yes.
So you mentioned the component of this test setup.
Yes, yes, sir.
Let
Yes,
me know the temperature required in the heater for the filament extrusion machine. The range of the temperature required.
It varies according to the. Yes, sir. It varies according to the material we use. We have used ABB, so we have kept it between 150 to 180, sir.
Degrees Celsius. Okay.
Yes, sir.
So the diameter of filament is always same. Yeah, we can vary the diameter.
We can vary, sir. That's why we have kept that die in a screw fit, sir. Like,
okay.
So we can change the die and we can get the diameter. And even if we are not able to change the diameter, if we strain the filament, sir, we can also vary. As we have seen that if we strain anything, it reduces its diameter.
So what is the production rate?
We get it evenly.
What is the production rate with the help of this extrusion machine?
Yeah. Yes. In 1 kg of wine, sir.
Okay. And the last question from my side: the cost of the test rig you have designed and manufactured or fabricated.
Okay, sir. As this idea was new to us and we were not knowing so much fabrication shops and the hardware thing, cost was it was about 12,500, sir.
Okay. This is from my side. Anyone want to ask question, please?
Yes, sir.
Majan sir. Hello, Majan sir.
Hello, Madan sir. Hello. आवाज येतोय sir?
Yes, sir. Your voice is audible.
Yes.
Okay, ma'am. Okay. Let's start now.
Okay.
Sorry for late join. Due to meeting, I have joined late, so sorry for inconvenience. I request the organizers to start the sessions.
Yes, sir. Thank you, sir. Sir, shall we move to the next presenter? I hear, sir.
Yes, please, ma'am. Proceed.
I would like to invite Prasad Kulkarni, sir, for review of various technique of optimization of machining parameter of ICON 718. Prasad Kulkarni, sir. Prasad sir, are you present there? Okay. I would like to invite Om Danish Bhangre sir, presentation on design and testing of novel solar dryer. Om sir. Om sir, are you present there? Okay. I would like to invite. Yes, sir. Yes.
Ma'am, project number 8. You missed the number 8.
Okay, Dhruvesh. Okay, I'm so sorry. I would like to invite Dhruvesh Savle sir for presentation on thermodynamic stimulation of combined power and ejector cooling system.
Hello. Am I audible, ma'am?
Yes, sir. Yes, sir, you are audible.
Yes. My screen is visible, ma'am?
Yes, sir, your screen is visible.
Yes. So first of all, welcome to the presentation. So I'm Dhruvesh Savle. I'm presenting the presentation in front of you about the topic thermodynamic simulation of combined power and ejector cooling system. So our guide name is Professor Dr. A.S. Dubey sir. So he is our guide. So the basic concept about our project is to, so basic concept of our project is to use the maximum waste heat recovery as well as to use the combining effect of cooling system as well as to generate the power from a single individual system. Okay. So our system is combination of organic Rankine cycle as well as the ejector refrigeration system. So organic Rankine cycle. So what organic Rankine cycle generally does, it is ideal cycle. So in which we have evaporator, condenser, expander, and pump. So in evaporator, we just heat the whatever the working fluid which is flowing through the system. Then in expander means generally it is a turbine from which we take out the energy output. And from condenser, we reduce the temperature, and after that we supply it to evaporator with the help of pump. Then ejector refrigeration system. So this system is one kind of cooling system we said. So this system starts from the boiler. So in boiler, we generally normally we heat the refrigerant up to certain temperature. So the temperature and pressure of this is after from the outlet of the boiler, the refrigerant passes to the inlet of the ejector. So what ejector generally does, ejector, the function of ejector is just to mix the refrigerant comes from the output of evaporator as well as the refrigerant comes from the output of boiler. So in the ejector, so the pressure generally increases, decreases, then also increases. That means the three phase of pressure. That means pressure increase, decrease, as well as increase. So this is the combined function of ejector. After ejector, the refrigerant is supplied to the condenser. So in condenser, pressure and temperature of the refrigerant decreases, and at the outlet of the condenser, so the refrigerant is divided into two parts. So the partial steam is conveyed to the boiler with the help of liquid pump, and partial steam is passed to the expansion valve to reduce the pressure, and from expansion valve it is delivered to evaporator. So in evaporator we get the cooling effect. So what we have desired, what we required. So it is all about the ejector refrigeration cycle. So the next slide shows the combined effect of the ejector refrigeration system as well as the Rankine cycle. So it is very simple. So if we just put the turbine in between generator and ejector of the ejector refrigeration cycle, we get the system. Okay. So if we eliminate from the system turbine, so we get the ejector refrigeration system. And if we eliminate the ejector and expansion valve, we get the organic Rankine cycle. So how this cycle works actually? So this cycle likely of ejector refrigeration system, this cycle starts from generator. So in generator, the refrigerant pressure and temperature increases. So after increasing pressure, this refrigerant pass to the turbine. So in turbine, whatever the electric output we want, whatever the power we want, is derived from the heat and pressure energy of the refrigerant. So after turbine, at the end of after the outlet of the turbine, so the refrigerant is passed to the ejector. So in ejector, as I said to you in previous, like as ejector refrigeration system, the pressure increases, decreases, as well as increases. So in this ejector also, the mixing of evaporator, refrigerant and turbine refrigerant occurs there. And so after the ejector, so the refrigerant enters into the condenser. So in condenser, so pressure and temperature of the steam decreases, and partial steam is converted to the generator with the help of pump, and partial steam is converted to the expansion valve. And after expansion valve, it is converted to the evaporator, and then refrigerant comes to the goes to the ejector for mixing. So this is our combined system. Excuse me. So what is the main biography behind all this system? So we have gone through various research papers. So in many of the research papers, researchers use the organic fluid such as organic refrigerant or blending of the refrigerant. So whatever the reference I have mentioned in that slide, so that so that researcher use R245FA and R600A. So blending of that two organic. Hello. Yes. So that researcher used the blending of two organic refrigerants for the working fluid of the combined system. So he gets the various results. So which is mentioned in the research paper of him. So abstract, what our system is generally does. So our system uses the refrigeration as well as produces the power output with the help of single individual system. So we have get the output. So what is the specific workflow of our analysis is? So what do in our research, so instead of the organic refrigerant or blending of organic refrigerant, we uses water as a working system, and we analyze water. How does water behaves in this system? We use the specific workflow. This workflow. Hello.
Yes. Continue, please.
Yes. So what a workflow of our system is. So first of all, we select the operating fluid. As I told you, we select the water as a working fluid. Then we check the thermodynamic properties of the water as a working fluid. Is this fluid is able to convey all the properties which is required for the combined system? So then we assume the temperature and pressure of the system. After that, we calculate the other properties with the help of temperature and pressure using Refprof software, which gives the other thermodynamic properties which is related to temperature and properties. So after calculating all the properties, we feed that properties in this SSMT software. So the full form of SSMT software is Steam System Modeler Tool. And if the result that we have get is satisfactory, then we goes with that particular refrigerant or particular temperature. But if the result is not satisfactory, then we have to assume the another temperature and according another pressure. So this is what SSMT looks like. So whatever the temperature and pressure that we have get from the Refprof software, so we have feed in that software. So like as pressure, temperature that we have assumed, and after that we have get the isentropic and generator efficiency from that software too. So as you all see that the software is getting some warning that inlet steam is contain condensate and steam condensing in turbine. So this temperature and pressure is not suitable for that system. Okay, so we have done many of the iterations for using water as a refrigerant using different temperatures and different pressures. So these are all the temperatures and pressures that we have assumed. But unfortunately, we doesn't get any output from any of the temperature and any of the pressures. So what is the conclusion of our project? So conclusion of our project is, when we use water as a working fluid, so what is the main reason behind not getting output of the water as a refrigerant in combined system? So for generating the power, the water is very much suitable because it has highest specific heat and that all. But the boiling point and freezing point of the water is very much the difference between boiling point and freezing point of water is very much large. So that's why the enthalpy or the entropy of the system is overlapping in the turbine. So that's why we are not able to use the water as a refrigerant in the system. So result from the analysis shows that water cannot be used as an ideal fluid, as it produces the energy or power, which is electrical power, but it is not suitable for the refrigeration. So apart from this, if we use the organic fluid or blending of organic fluid for the system, this system gives the better refrigerating effect, but we shouldn't get the considerable power output. But some minor power output we should get. So for that, if we have the applications of considerable power output and the refrigeration effect, we can use the blending of the organic fluid or simply the organic fluid in the system. So that's what our project is. So these all are the research papers that we have gone through. So thank you. If you have any questions, so you can ask.
As you said, you're not supposed to use the water because of the boiling point and freezing point difference.
Yes.
So which fluid you can propose so that the difference is minimized, or it will be help to produce the enough power? As you use the word minor power as using different organic fluids. So which fluid is suitable, which will give the maximum power? What do you think?
Sir, so we have gone through various of the research papers. So from that research papers, we come to know that the blending of R245Fa and R123. So blending of this refrigerant gives the maximum power output, and that means considerable power output and the good refrigerating or cooling effect.
What is the difference between their boiling point and freezing point? How much is the difference?
So I'm not able to get that at this moment, sir. Sorry.
Okay. Madan sir, you may.
Any more questions from the respected judges?
So where is this device or system is used? Tell me some applications where you can use this ejector refrigeration system for cooling purpose.
So if we want the cooling effect, that means if we want the cooling effect such as the cooling effect we get in the malls, we say, or any of the auditorium or theater, we say. But with the help of that cooling effect, if we want some small kind of power, so we can use that system in that place. So for the combination of cooling effect as well as the power, so we use this system in that place.
Okay. Anyone want to ask question from the audience? Okay, thank you, Durvesh.
Thank you, sir. Thank you.
So shall we move to the next presenter?
Yes.
Yes, sir. Thank you, sir. I would like to invite Professor S.B. Ambarkar, sir, for presentation on design and development of Earth analysis.
Good afternoon, ma'am. My name is Ashish. Professor Ambekar sir is my guide.
Okay,
so This is my topic. Okay. Thank you for giving me this opportunity. I'm going to present now.
Yes, sir. Yes, sir.
Okay. So design and development of earth analyzer. This is our title. And SP Ambekar sir is our guide. Okay. So in next slide about the biography. Actually, we were doing some soul searching about this idea and came to the conclusion that we should make a project in the agriculture sector as per our guided us. And then we thought of automizing the agriculture field, and how can we automize it? Okay, so we came to this idea of soil testing. Okay, in this process there is in this process there is many operations where you can analyze the soil and extract their phenomena like pH scale, scale, then the temperature, then the moisture, ammonia, etc., which is the crucial elements to grow a crop. Okay, so that's why we decided to make a project which can automize a field and make it as a farmer can do it very efficiently, the soil analyzing. Okay, moving on to the next slide, the abstract. The main purpose is to uh, uh, giving a productivity to a farmer, because productivity of the field, increasing the productivity of the field and giving it to farmer, so he can based on the analysis he can see what the crops are getting the nutrition or not, or everything with the help of a rover which will go on and analyze the field for him. This is an IoT based project, so there is a rover which we made in our last year as our last year project. What is soil analysis? In short, soil analysis is like we have to need these tools, as you can see in the picture, that you have to get a sample of 5-6 samples, then up to 6 inches you have to dig a hole, mix it well, then rocks and vegetation you have to remove that, all the things, label it and give it to the tester, means the chemist lab which is near. Okay, so or the officer who is going to test. Okay, so we have to go there, do all these things to get the results what we need. It is a time consuming process and sometimes leads to days and days of waiting. So there is what we can say, a time loss in what is done with the farmer. So for the well-being of the farmer, the description about the projects are means what our project is consist of. It is consist of a node MCU, which is a microcontroller. ESP28266 is the microcontroller we are using. It is a Wi-Fi module which provides us information and feedback on our phone, so we can connect with the Wi-Fi and see what is going on in the field. Then next is the motor driver, which drives the motor, and the rover can travel to the field. Next is the DST11. DST11 is a sensor which senses the temperature and humidity of the surrounding, the atmosphere. Then there is moisture sensor, the crucial element which senses the soil moisture, which is most needed for our plants. And this is the block diagram which provides us about the information what is happening actually. So in the center you can see the node MCU is there, node MCU, the microcontroller. Then this is attached to the motor driver. Motor driver means the node MCU sends signal to the motor driver. The motors is controlled. There are two motors which controls the wheel movement, sorry. The power supply is connected to the MCU. Then the display and the blink app is connected. Blink app is an app on which you can see what is happening inside the field. Then which is currently available on your means it is app, so you can remotely see your what is happening in the field on your mobile phone and display. The Below that are the all the sensors, like moisture sensor, soil moisture sensor, then DST11, then DST11 for humidity, and then the ammonia sensor, which gives a hint of pH level. Okay. Then about the working, so what our project do actually? So we have to take the project and land it in the field. Between the two lanes of crop, it will travel, and after some intervals of time, it will stop and analyze the temperatures and humidity and all these things. Then it will update it to your phone, and you can see the live interaction of the field, what is happening in the field, and on your mobile, on the spot. So it is on the spot working process. So these are some results we got. We analyzed it in the fields, various fields like jawar, wheat. There was some data we grabbed from the internet, and some data we actually gone and tested on the fields, like tomatoes or onions, like strawberries, and wheat, jawar, which was readily available. um, so you can see this spreadsheet where the moisture column is there, ideal and actual. So what actually we are getting and ideally what we want. So jawar, as you can see in the jawar, the ideal was 2 and 50 percent of the soil moisture, but it was around 18 or 17. So it was low. So we told them that you should water it as per the schedules, and do not make this soil uh, less dry and all these things. Then temperature and humidity, actually the climate, here what the climate perspective comes in. If the climate is not good, then he can the machine can detect that this temperature and humidity, on the basis of temperature and humidity, that the rain is going to fall or something, as something is coming, like on the spot, we can say weather detection. So that aspect also we joined it in the last year project, our last year project. So in the conclusion, we made an IoT based project which saves the wastage of plant because of the low quality soil. And also we made it pretty clear that with the help of moisture and humidity, we can sense the um, climatic conditions and act as per. So this is most beneficial project for the farmers. And also the farmers, and the some crops are which used to be need to be in a controlled state, in a controlled environment, like bell pepper, or some foreign plants, like we can say the snake flower plant, or there is many plants of flowers which are very very sensitive to the weather and something and everything. So that is what the conclusion of our project is. So references, these are some references which are the generals we referred for the agriculture soil moisture testing, and the new researches what are going on nowadays. And thank you. If any questions, please do ask. Thank you. Yes.
Yes, Ashish, good idea. Okay.
Yeah, yes, sir.
For this earth analyzer.
Yeah, yes.
Let me know the idea behind this project.
Yeah, yeah, idea, sir. Actually, the main idea is like the what is happening inside the soil. We don't know, right? Like moisture. What is the moisture of the soil? Then what is the pH level of the soil? Then what is the NPH? These are three potential elements you need. N stands for nitrogen, P stands for potassium, P stands for phosphorus, and K stands for potassium. So these are the main needed elements for the plant to grow. And sometimes because of this, unnourished plants can be grown, and because of that our farmer face a much difficult situation, because the crop is not that good of yield, and that's where the problem comes. and because of that problem statement which we read on the internet, we loved the idea that we can do something about the fields and how to automate the field. Many researchers are coming out, like vertical agriculture and CNC farming, like these concepts are coming up. So we thought we should also do something innovative which is partially in robotics and in mechanical field. So that was the main idea behind it, sir.
Thanks. Thank you.
Yeah.
Second question, the total costing of your project.
It was around, sir, 5,000 rupees, because the coding was done from outside, but all the manufacturing was done inside the workshop which my father owns, sir. So
Yes,
that
okay,
was a
okay.
benefit. But around 5,000 you can make the cost less if you go for the mass production, or
Mass production.
yeah,
Okay.
yeah,
Yes.
you can make it up till 3,000, 2,000. So it is a very beneficial product which you can give to the farmer, and he will say, okay, let's on it and let's see what is happening in my field.
Yes, yes. Good, Ashish. Keep
Yeah.
it up.
Yeah, thank you, sir. Any further questions? So should I stop presenting?
Any more questions from the respected judges?
Audience, any questions, please? Yes, Ashish, you can stop.
Okay, thank you, sir. Thank you for the opportunity.
Thank you.
Thank you, sir.
So should I leave, ma'am? Or
Yes, sir. Yes, sir.
yeah, thank you.
Next
Yes, sir.
participant.
Yes. I would like to invite Prasad Kulkarni, sir, for review of various techniques of optimization of machining parameter of INCON 718. Prasad Kulkarni, sir. Prasad, sir, am I audible to you?
Next, please, ma'am.
Yes, sir. I would like to invite Danish Bagde, sir, presentation on design and testing of novel solar dryer. Sir, are you present there?
तिथंच ठेवलेली त्यांच्याकडे सॉफ्ट नाहीये त्यांच्याच पीसीवर पण ती पण
I would like to invite Professor Kaustup P. Joshi, sir, for presentation on comparative analysis of 3D printed tensile component.
Hello.
Yes, sir. Kaustup, sir, are you present there?
On the behalf of Kaustup Joshi, sir, he was our guide. So I'm going to present our research on comparative analysis of 3D printed tensile components.
Okay.
So we were 4 members in our group, and our guide is Professor Kaustup P. Joshi, sir. So our main motive is to analyze the infill density and orientation pattern in 3D printed components. So 3D printing is referred as a process that deposits a printed material onto a powder bed. It actually it is a formation of product in the layer formation. So the main problem with the 3D printing is that we don't decide how the actually those are plastic materials. So we can't determine how much good are they in strength. So that's why we printed it in various orientation to make how much they can sustain the tensile strength. So for that purpose, we use Anet 84 Pro 3D printer. These are second image is the orientation we have selected. This is the X, this is Y, and this is the Z. So in this three orientation, we have printed about 18 components. So we can get an accurate value of the tensile strength. This is the tensile testing machine we have used. It is the UTM. These are the some images of our components after printing, and this is the image of component in clamping UTM. So according to our first analysis, so we have concluded that PLA at y-axis gives more strength than others. So for further analysis, we just take 40, 60, and 80% of infill density in a PLA y-axis. So in 40% density, you can see the cubical pattern in the infill pattern, cubical infill pattern, and you can see the load versus displacement gap. At infill density at 40%, the ultimate tensile strength was 41.67 mm Newton per mm square. For 60%, it was 43.24 Newton per mm square. For 80%, it was 45.69 mm square. On this basis, we can conclude that for our required load, as per our load requirement, we can take the different infill pattern in different orientation. So this was our conclusion. These are the some research paper we have referred. Thank you.
Okay. So for this 3D printed tensile components, whether it is a plastic one or some metal is used.
Material, we have used plastic materials, ABS and PLA. We have taken two materials.
For
our first analysis.
So after analysis, you got the better strength.
Yeah.
Than the conventional components.
Yes, sir.
So what about the cost of the components with the help of this 3D printing?
One component with tensile test cost us about 700 rupees.
And conventional, with respect to conventional, how much is the difference?
Sir, the difference is it is not a full research. Actually, it can be referred as a it is also research, but it can be referred as a base for further researches. It just gives us idea that we can save our time and our material in as we can use the different infill density.
Okay. Okay. Anyone want to ask question from the audience, please? So Vaibhav.
Yes, sir.
So this is a latest topic. You can go through for the different materials comparison with the conventional material and analysis.
Yes, sir.
So keep it up in your future for the research work.
Okay, thank you. May I stop sharing, sir?
Anyone want to ask question, please? Okay, Vaibhav, you can stop your presentation. Next one, ma'am, please.
Yes, sir.
Thank you.
Like to invite Praveen Chahal, sir, to prepare presentation on to maintain air quality and ultraviolet sanitization for indoor environment, a review. Praveen, sir, are you present there? Am I audible to you? Praveen sir, am I audible to you?
I think he's not there. Next, please.
Okay, sir. I would like to invite Shubham Samant sir for presentation on design and development of solar panel cooling system. Shubham Samant sir. Shubham Samant sir, am I audible to you? Are you present there? Okay. I would like to invite Harshvardhan Patil sir for presentation on performance improvement in gas water heating system. Harshvardhan Patil sir, are you present there?
I think he is also not there.
Okay, sir. I would like to invite Rishikesh Hirari sir for presentation on design and development of mobile operated smart solar gardening robot. Rishikesh sir, am I audible to you? Rishikesh sir? I would like to invite Professor Sachin Chhede sir for presentation on design and implementation of material handling trolley in heat treatment section. Sachin sir,
Yes,
am I audible to you?
Yeah, you are audible, ma'am. Ruturaj Bua is going to present.
Okay, sir.
I hope he is meeting. Yeah, he is presenting, ma'am.
Yeah.
Good morning, ma'am. Good afternoon, ma'am.
Good afternoon, sir.
Actually, I am facing a technical glitch on my side and I am trying to connect from my laptop. So need a few moments.
Okay, sir.
Ma'am, can we take the next one? I'll present in the next part. Means next.
Okay. Okay, sir. Okay. Yeah. Would like to invite Priyanka Kadam ma'am for presentation on design optimization and thermal analysis of disc brake rotor of two-wheeler.
Yes, ma'am.
Yeah.
Hello, everyone. Are you visible, ma'am?
Yes. Your screen is visible, ma'am.
Okay. Hello, everyone. First of all, thank you so much giving me a chance to present my work. I am a Priyanka Kadam. My title of my project was design optimization and thermal analysis of disc brake rotor for a two-wheeler under the guidance of Professor Dr. S.S. Gowde sir. So here is the biography. So we know that the disc brake is a device that means artificial frictional resistance applied on moving machine, means rotor is converted is order to stop the motion of machine. It is one of the most important safety component in automobile and it absorbs the kinetic energy of the moving member. So here is the one of the picture of the disc brake rotor. Here is the abstract. In my project work, the abstract is disc brake. Disc brake is a device by means of artificial frictional resistance is applied to moving machine member in order to stop the motion of machine. In the process of performing the function, the brake absorb the kinetic energy of moving member and dissipate the absorbed kinetic energy in the form of heat. The main objective of this work is to investigate the temperature field and structure field of the disc brake rotor during the braking condition, and the three-dimensional modeling disc brake done by using the CATIA V5 tool, and the analysis done by using the ANSYS Workbench 14, and the steady state thermal analysis are used to find the temperature field. And the steady state thermal analysis to find the deformation and one measure stress established on the disc for the all designed disc brake. The thermal analysis evaluate the temperature distribution and hence the best design of the rotor suggested for based on their purpose in terms of heat dissipation. So here is the literature gap. The majority of the work done in different types of the materials. There is limited study on thermal analysis. So need to determine the temperature and determine the temperature. Here is the problem statement. The disc brake piston exert the pressure on rotor disc and the temperature of the rotor disc increasing. The temperature increasing due to the temperature increasing the thermoelastic expansion of the rotor. This going to affect greatly on performance of the disc brake. The modification design modification is necessary for enhance the disc brake rotor performance as well as thermal performance. So this work fulfill these needs. Here is the modeling of the original disc brake rotor for Bajaj Pulsar 150cc based on the standard dimension available on website. The drafting of the 3D modeling with the help of the CATIA V5 R21 software, and the inside and outside diameter is 240 mm and inside diameter is 110 mm. Here is the first one design I have prepared. Same the dimension as per the original dimension. The inside outside diameter similar, and there is 6 inside the holes. 6 inside the holes and with their diameter is 6 mm, and outside the holes the total 36 holes and having diameter is 8 mm, arranged at same distance and with the help of the circular pattern command. Here is the second disc brake rotor model I have prepared, similar as dimensions as the original disc rotor. The 6 inside holes having diameter 6 mm and 8 outside holes having diameter 8 mm. Here is the fourth one, disc brake rotor. Original disc brake rotor is reduced with 6 holes inside. Their diameter is 6 mm and 19 hole outside the surface, and diameter is 8 mm by using the same command. So after the modeling, I go for the static structural analysis, which done by using the ANSYS software. Here is the boundary condition. I have apply the force along the x direction. The force along the x direction. The inside all the holes are fixed, and tangential force is 1000 Newton. The material of the disc is gray cast iron. In steady state analysis, I have found that the trace on original disc brake rotor is 1.9083 into 10⁻⁷ Pascal, and the trace on another new prepared disc brake rotor is 2.960 into 10⁶ Pascal. For the third rotor, the trace is 3.186 into 10⁷ Pascal, and for fourth one rotor, the trace is 3.7619 into 10⁷ Pascal. Here is the deformation of the all 4 type of the rotor. For the original rotor, the deformation is 0.003691 mm. For the rotor second, the deformation is 0.0044 mm, and for the disc brake rotor third, the deformation is 0.003541 mm. For the rotor fourth, the deformation is 0.005629 mm. After the steady state analysis, I go for the steady state thermal analysis. The steady state thermal analysis are used to determine the temperature field of the disc brake rotor. For the original disc, here is the original disc brake rotor, and the temperature is 250 degrees Celsius. And the new designed disc brake, the temperature is 110 degrees Celsius. Here is the third one disc brake rotor having temperature steady state temperature is 135.61 degrees Celsius, and the fourth rotor the temperature is 117.51 degrees Celsius. After the steady state thermal analysis, all the after observation of all the temperatures, we found that the temperature of the rotor disc second is 110, and it is a minimum temperature. So I prepare the steady state transient thermal analysis for the disc brake rotor second for the 1 hour. After 10 minutes, the maximum temperature 105 degrees Celsius. After the 20 minutes, the maximum temperature 10 degrees Celsius, and after the 30 minutes, the maximum temperature 111 degrees Celsius, and then after 50 and 60 minutes, the temperature remains same and that is 111. Here is the result of the all result. Here is the result table of all the disc, including the original disc brake rotor. The first column indicate the trace into 10⁷ in Pascal, deformation in meter, and the temperature in degrees Celsius. Here is the comparison. Here is the one graph plot on the basis of result. This graph, this one for the original disc brake rotor. This graph for the second disc brake rotor. This graph for the third disc brake rotor, and this one fourth disc brake rotor. So in this graph we observe that the disc brake rotor second having minimum temperature. Here is conclusion. From all above the result comparison, it concludes that the thermal analysis as well as transient thermal analysis, the heat dissipated maximum for disc brake rotor 2 as compared to original disc brake rotor and other new designed disc brake, the minimum temperature obtained the disc brake rotor 2 in contact surface, and it is 113.08 degrees Celsius, and original disc brake rotor the maximum temperature is 250 degrees Celsius. The possible reason behind the sustaining the high temperature due to change the shape of the rotor, that is maximum ventilation area around the disc brake rotor. The present study can provide the useful design and improve the brake performance of the disc brake rotor system. So here is the references I have used for this work. Thank you. Is any question?
Priyanka, good work.
Thank you.
We have done a lot of work on disc brake rotor. There are some
yes.
queries or questions from my side. For the designing of this rotor, disc brake rotor, which parameters you have selected for designing purpose? Parameters.
Sir, inside diameter, outside diameter.
And at the time of presentation, you show some figures about the rotor. Some holes are
Yes, sir.
provided. So why there is a requirement of such holes on the disc brake rotor?
Sir, due to the holes and slots, we can improve the cooling efficiency in braking conditions. So this helpful for reducing the temperature.
How it helps
That's
to
why
reduce
I
the
have used
temperature? Which mechanism? Okay. Okay. Now, one more question is there. You have used different diameter of holes for the rotor.
What, sir?
Different diameters.
Yes,
So, what is the effect?
no, sir. No, sir. All the rotors having same diameter, but inside the slots and holes having different arrangement.
So why there is a different arrangement is made on the rotor? What is the logic behind it? Whether it is useful to increase its performance?
Yes, sir. It is useful to increasing the braking performance.
So, which material is used for conventional disc brake rotor? Original disc brake rotor.
Sir, gray cast iron material are used for this.
Okay. Anyone from the audience? Okay, Priyanka, you can stop your presentation. Good work.
Thank you, sir.
Next one. Okay. Next one, please.
Yes, sir. I would like to invite Sunil Gyole, sir.
Yes, ma'am. Yes, ma'am.
Investigate the impact of riser tube shape variations on flat plate solar water heater performance using CFD analysis.
Can you see my presentation?
Yes, sir. Your screen is visible, sir.
Okay. First of all, good afternoon to all of you. Today I am going to present my research topic that is investigate the impact of riser tube shape variations on flat plate solar water heater performing using CFD analysis under the guidance Dr. Ajay U. Aute, sir. This is the abstract. Okay, the main focus is how the flat plate collector works for different riser tube configurations. This is the main focus of this research work. And for that, here CFD analysis is carried out to find out the result and for optimization of riser tube configurations. Here, all of you know that the need of solar energy, the world's energy needs are currently being met by traditional sources, and fossil fuels have two major drawbacks. First one is they have limited in quantity, and second, they pollute the environment. That's why renewable energy sources overcome these drawbacks of traditional energy sources, and also the solar energy produce no pollution while burning of fossil fuels and release this roughly 21.3 billion metric tons of carbon dioxide into the annually due to the burning of fossil fuel, and this is overcome by the solar energy. And the challenge is to capture the solar energy and increase the efficiency of the solar flat plate collector. Here the applications in solar drying, solar distillation, solar cooker, solar furnace. There are a lot of applications of solar energy. This is the working principle of solar collectors. Here the sun collector takes the radiation from the sun, and this heat energy is then transferred to the absorber plate. The absorber plate absorbs the heat energy and transfer it to the working fluid. It may be water or air, and this heated water and air then used in different applications. This is about the construction of flat plate collector. Flat plate collector consists of glazing or a top cover. It may be one or two, the absorber plate, and the riser tubes bonded to the absorber plate, and thermal insulating materials. These are and casing. These are the main components of flat plate collectors. Okay. In literature review, some of the authors have remarked some things here. The thermal performance of solar hot water system using a flat plate collector of accelerated riser tubes by Kei Amori, and Kei Amori has suggested that the accelerated riser will enhance the thermal performance of the thermosiphonic solar collector because it will increase
yes,
the
Sunil, please change your
hello.
Your slides are not
change
moving,
your
sir.
PPT.
Hello.
Sunil sir, your slides are stuck at the second one. Please move your slides.
Okay. This is about my problem statement. The objective is the study is to analyze the effect of various geometric configuration of riser tubes, and modeling is to carry out the ANSYS CFD tools. Here the three cross sections.
Same slide is visible to us. Please change it.
Yeah. Sunil sir.
Okay.
So you want still on the second slide. Please just move on that review slide.
Here we can you can see now.
No sir, no.
Are you see my presentation?
Yes. Please go ahead.
There are okay. The problem statement is the objective is to analyze the effect of various geometric configuration of riser tubes, and modeling to be carried out with ANSYS CFD tools. Here the three cross sections of riser tubes are taken. First one is circular, then square and triangular. This is the circular riser tube configuration. The length here the length, diameter and thickness of the
yes sir, you can continue.
Circular riser tubes dimensions are given here. Length is equal to 0.72 meter, diameter 0.01 meter, and thickness is 0.001 meter. Okay, similarly for square and triangular riser tubes, the dimensions are taken, and the dimensions are selected such that the cross section for all the three sections should be same, so that the mass flow rate all the three cases. So in methodology, here the experimentation and CFD simulations are carried out for all the three shapes: circular tube, square tube, and triangular tube, and the result obtained is then compared. Okay, here I use the TES 1333 solar power meter for readings of solar radiations, And here I use the solar energy data site Solaris for the Shirpur location. Okay. Then these are the some boundary conditions. In boundary conditions, CFD analysis, mass flow rate is taken 0.0038 kg per second with constant inlet temperature, and the readings were taken at 10 a.m., 12 noon, and 2 p.m. These are the input parameters for simulation: the density, specific heat, thermal conductivity, density, viscosity, specific heat of water, thermal conductivity of waters, and these are the values. Okay. Then some assumptions are made. The water is circulated through the absorber tube, and the water is continuous medium and incompressible. The flow is steady and laminar. Okay, and the thermal physical properties of the absorber plate, water, and the absorber tube are independent of temperature. These are the assumptions. In CFD analysis, the three domains, for three domains, circular, square, and triangular, is carried out. This is the mesh model of circular riser tube, and this is the temperature distribution for in circular riser tubes. Okay, and these are the results obtained for the square riser tubes, the temperature distribution for square riser tubes, and the CFD simulation is performed on square riser tubes for 706 watt per meter square radiations at 12 p.m. Okay, all the three shapes, the readings are taken at 12 p.m. and for radiation 706 watt per meter square. This is for the triangular riser tubes. Okay, and this is the efficiency of flat plate collector. How will you calculate the efficiency? The efficiency is calculated by using the useful heat gain divided by the product of total solar radiations and the collector gross area. Okay, the efficiency is equal to QU divided by IT into AC, where IT is the total solar radiation, AC is the collector gross area. Okay, and Q is the useful heat gain. Okay, QE is also calculated by the equation EM Cp delta T, where EM is the mass flow rate, Cp is the specific heat of water, and temperature, outlet temperature and inlet temperatures are considered to calculate the useful heat gain here. These are the results obtained using CFD analysis for
based on the adaptation logic and
triangular, square, and simple circular tubes. Here, the useful heat gain for all the three conditions are given in the table. The results are obtained, and it is shown by the table. And the graph shows the outlet temperature difference between the square, triangular, and simple circular tubes is almost 2 degrees centigrade. Okay. Then comparison of collector efficiency. The collector efficiency, this is the table showing the comparison of collector efficiency, and the graph shows that the more efficiency is obtained in case of square and triangular absorber tubes as compared to simple circular tubes. Approximately 8 to 10% rise in efficiency. Okay. Then this is the comparison of experimental data with CFD simulation data. The results obtained from experimental experimentation and CFD simulation. It is tabulated in this table, and it is shown that the experimentally measured temperatures and the temperatures determined by the CFD analysis are found to have a good similarity. Means experimental results are validated, or CFD results are validated by experimental results. Okay, there is a very much or very good similarity between the experimental and CFD analysis results. This is my conclusion. The square and triangular riser tube configuration gives the maximum outlet temperature of water for the same heat flux and inlet temperature as compared to simple circular geometry. And we get the outlet temperature 200 degrees centigrade more in case of square and triangular riser tubes as compared to circular one. And the efficiency is increased by 8 to 10% by using square triangular absorber tubes configuration as compared to circular tube configuration. These are my references. Thank you.
Thank you, sir.
Okay. So for the CFD analysis purpose, you said that the mass flow rate consider is a 0.038 kilogram per second. Why only this value you have considered for the analysis purpose?
We consider,
why not another?
We consider the 5 members family, and approximately 10 liters per person is required, and for 50 liters daily hot water is required, suppose for bathing. Then the mass flow rate is calculated by using the cross section of each tube, and the mass flow rate is obtained 0.0036 kg per second.
Okay. You have selected circular shape, square shape, and triangular shape.
Okay.
So out of these three, are there any shape where the researchers have their
many of the researchers have try for the oval shape as well as accelerated shape. At one end, the diameter is half at compared to other end.
Okay. So after analysis, you told that the square and triangular shape gives the better output.
Okay.
So what is the mechanism? What happens with the shape of the square and triangular?
Because there is a in case of square and triangular riser tubes configurations, there is a better contact between the absorber surface and the riser tube surface, because there is a flat patch, and that's why the heat transfer takes place more as compared to circular one.
Okay, yes. Last question. What is the percentage error between experimental results and CFD results? You said it is very close to each other, but have you calculated the exact percentage error?
I have calculated the experimental result and CFD results and compare them. Only 1 to 2% variations in experimental results and CFD results.
Okay, good. Go ahead, please. From audience, anyone have questions? Please, you can ask. Audience.
Hello. My question is it possible to manipulate the CFD data?
Not, sir. It is not possible to manipulate the CFD data.
Because in software, there is always a possibility that we can vary the inputs according to our output requirement.
But sir, if while you perform the CFD analysis, you have to select one of the station, or we can say location, to collect the solar energy data. And for particular data, we have to carry out the CFD analysis.
Okay. So only temperature you measured?
I measure the useful heat gain and temperature, outlet temperature, and also efficiency.
So heat gain you have not mentioned?
Yes, sir. I have mentioned heat gain. One more here. This is a comparison of useful heat gain.
Yeah, in the last table.
Can you see my
Yes, yes.
presentation
Yes.
here in PPT? The PPT shows the comparison of useful heat gain. First PPT.
Yeah, how you measured this?
This useful heat gain is calculated by mCp delta T.
Okay.
Inlet T0 means outlet temperature and Ti means inlet temperature, water temperature, both.
Okay. Okay, thank you.
So, next one, please. Ruturaj.
Yes.
Okay, thank you, sir.
Yes, sir. Ruturaj, sir.
Yes, sir. Yes, ma'am. Good afternoon.
Good afternoon.
Is my screen visible, ma'am?
Not yet, sir.
Now?
Yeah, it is visible, but presentation has not opened there.
Oh, actually, I have a problem with my PPT. It is completely blank, means corrupted or what, I don't know. So this is the paper which I have submitted for the conference.
Okay.
So good afternoon, myself Ruturaj Bua, working under the guidance of Professor Sachin Chhede. So the title is Design and Implementation of Material Handling Trolley in Heat Treatment Section. We group of 4 students were working in Birla Precision Tools, Nasik, and this is a hands-on project on which we are working. So this is the image of the trolley for which we will be giving the automation. The dimensions of the trolley are 154 by 154 by 120 centimeter, and the weight to be carried in the trolley is around 500 to 600 kg, which was a heavy ton. Actually, the process inside these buckets are cleaning purposes, which used for further heat treatment of the product. So this trolley was to be moved for the distance of about 50 to 60 centimeter. The main objective of this trolley the main objective was to design a rack and pinion mechanism for movement of trolley. The time required to be reduced and to improve and to reduce the fatigue of the operator. So by considering various methodologies for movement, we came with various possible mechanisms. The first one was hydraulic piston and cylinder mechanism, lead screw mechanism, and gear mechanism. The hydraulic cylinder and piston mechanism was more costly and required more maintenance. Lead screw was not feasible for the industry. So we came up with a rack and pinion mechanism, and gear train was neglected because of more wear and tear. So this was the process flowchart for rack and pinion mechanism. The analysis was done using ANSYS. Fabrication was, in short, we were completely helped by the industry in making this project. So while after the manufacturing was completed, we went on to testing. These were the primary considerations of the assembly, wherein motor was the prime mover, gearbox was used for speed reduction, coupling for connection between gearbox and transmission shaft. A plumber block was used to reduce the vibration, which was suggested by the industry, and we did not consider during our primary design. And pinion and rack. So this image shows that how was the rack and pinion to be implemented on the trolley. This tabular data shows the time required for process before automation and after automation. So average time was reduced by 30%. The average time was reduced by 30%. And the future scope for this project is we can implement PLC or microcontrol, implement sensors. Okay, so with this, I conclude.
Okay, Rutraj.
Yes, sir.
So this is a sponsored project?
Yes, sir.
Which company?
Birla Precision Tools, Indian Tools. Birla Precision Technologies, Indian Tools, Nasik.
Nasik. Okay. So the project is related to the trolley, material handling trolley in heat treatment section.
Yes, movement of the trolley.
Movement of the trolley. So what is the range of the temperature in a heat treatment section?
Actually, sir, that was the consideration of their part, which means first, the Birla Precision Technologies main product is the drill bits. They manufacture the drill bits. Then before sending it to the heat treatment, means quenching or that, they clean it.
Okay.
They clean it using HCl and then water or soda. All these means HCl, water and soda and some saline. I don't know. I just don't remember, that were on these 4 buckets.
Okay. So for the operating purpose of the trolley, rack and pinion mechanism you have selected.
Yes.
So why you selected this one mechanism?
Okay.
Why not another mechanism?
Rack and pinion mechanism was the only mechanism which company suggested us. Before going with rack and pinion mechanism, we also suggested the industry to go with lead screw mechanism. Initially, we designed a lead screw mechanism, but then they said that phosphorus bronze is not expected to give the higher efficiency as compared to EN24 material, which will be used in rack.
Okay.
So this flowchart shows that why we denied the other mechanisms and took only rack and pinion mechanism. Hydraulic piston and cylinder mechanism was more costly, required main maintenance, and chances of leakage was also high. Lead screw mechanism was, as I said earlier, that phosphorus bronze will not give the expected efficiency. And gear train is a bulkier system, heavier, vibration will also occur. So more number of more number of plumber blocks should be implemented, and rack and pinion was the only in this method. So we choose rack and pinion mechanism.
Okay. Last question. What about the cost of your project? Performance, there is a reduction in time average. Okay. But what about the cost of the project?
Cost of the project means, sir, only assembly had costed it cost around 28,000. But the payback period which the payback period is 6 months, which we will be taking the means amount of 28,000 will be recovered in the 6 months itself.
6 months span of.
Yes.
Okay. Good one. Good project.
Thank you, sir.
So from the audience, if you want to ask question, please.
Yes.
Any more questions from the respected judges?
Okay, Ruturaj, you can stop.
Thank you, sir.
Okay.
Iyer sir, with your permission, can we call the previous presenters once?
Please give them a chance, one more chance to present their work.
Yes. Thank you, sir. I would like to invite Kuldeep Singh Satish Patil, sir, for presentation on wireless smart electrified road for EV with dynamic and static charging by solar energy. Kuldeep Singh, sir. Okay. I would like to invite Pramod Bharat Deore, sir, for presentation on IoT-based smart production line. Pramod, sir. I would like to invite Danish Abdul, sir, for presentation on performance evaluation of cooler operating on solar.
Next one. Kiran Sajan Pawar. Design and development of portable bricks machine using neural leaves.
Hello. Hello. Yes. Next, Yash Bhaviskar, are you present? The topic is effect of aging on performance of ice plant test rig. Yash Bhaviskar. The next paper title is Design and Modification of Banana Fiber Extraction Machine. Aniket Dubje. Are you present? You want to present? Hello. Yeah. The next topic is review of various techniques of optimization of machining parameter of Inconel 718 under the guidance of Prasad Kulkarni, sir. Are you there? Hello. Next title is Design and Testing of Novel Solar Dryer, Om Bagde. If you're ready to present, you can share your screen.
Excuse me, sir.
Yeah, please.
Actually, sir, Om Bagde is not present. I am his group partner, Rohan Dixit.
Okay.
So I would like to present, sir.
Yes, go ahead. You can share
Yes,
your
you can present. Yes.
presentations, share the screen, and you can start.
Okay, thank you, sir.
Yeah.
Can you see my screen, sir?
Yeah, we are able to see it, but I don't think this is your presentation.
Yes, sir. Actually, Om Bagre, there is some medical emergency. So he is not able to send me that PowerPoint presentation or paper. So I have our college sir report, sir, and I would like to present it.
Okay, okay. With the permission of IR sir, shall we proceed?
Yes, please go ahead. Please.
Yeah, go ahead.
Thank you, sir. So, our project title is Design and Testing of Novel Solar Dryer. Our group guide is Mr. Dr. N.L. Virud, sir. With his guidance, we would like to design a solar dryer. The solar dryer is not a concept which we newly added. It is used from the ancient times. The thing we added in this that the ordinary machines or the techniques used for drying the crops or vegetables in the open nature or in the direct sunlight. So we are going to use that sunlight with the help of some container techniques at where the heat is trapped and the crops are well dried in a clean nature. I would like to show you our actual model in a 3D format. This is our actual model in 3D. We use a polypropylene plastic material to make this part. We also use a acrylic fiberglass a for heat trapping purpose and direct sunlight trapped on the act on the crop. Then by using these techniques, we get these are the results. At no load condition in a solar dryer, we use time for 12 p.m. to 4 p.m. at atmospheric temperature in open nature. So it is 43 degrees Celsius to 72 degrees Celsius. These are the temperature difference we get. And in a load condition, we do a comparison that we dry. These are the onions in our solar dryer and in open nature. So in a solar dryer, we dry 200 grams of onions. The final weight of these are 250 grams. So the weight loss is 1750 grams. And in open nature, we also dried a same 2000 grams of onion. So the final weight of that is 556 grams. And so weight loss is 1444 grams. These are the results we get from our solar dryer project. These are the parts of our solar dryer project. This is the base of the project, which is made from the plywood. We also use a aluminum steel for our project. So this is it about our project, sir. Any questions?
Okay, design and testing of novel solar dryer. Why this word novel is used? What is significance?
In the term, sir, no one which is portable and compact. So these are our model in TV screen types. When we disassemble the project, it is just 30 centimeter thick.
Okay, okay. And project cost?
So our project cost is about 3,000.
Only 3,000?
Yes, sir.
Okay, it is a cheap one.
So this is used for the domestic purpose. That's why we manufacture this product.
Okay, okay. ठीक है. Anyone want to ask question? If you have any query, you can ask.
Any questions, respected judges? Extremely sorry, I guess, sir, as I'm facing some network issue.
No problem, ma'am. We continued with the further topics, and somehow Rohan Dixit was able to present on his topic.
Okay, sir. Thank you so much, sir, Sachin sir, for taking care of it. Thank you so much.
No, it's okay, ma'am. It's okay. The next title is number 13, to maintain air quality and ultraviolet sanitization for indoor environment. Praveen Chahal, are you ready to present? Hello. Okay, shall we move ahead for the next? Design and development of solar panel cooling system. Shubham Sawant. Shubham, are you there in the meeting? Want to present? Okay, one more chance to Harshvardhan Patil, performance improvement in gas water heating system. The title of the paper is Performance Improvement in Gas Water Heating System. Are you there, Harshvardhan? Okay, and the last paper title, one more chance given to him, Rushikesh Birari sir, Design and Development of Mobile Operated Smart Solar Gardening Robot. Are you there, Rushikesh? Yes, ma'am, we are done with our technical session 1A.
Yes, sir. Okay. Thank you so much, sir.
Yeah, what are the further guidelines now?
So out of 19, only 8 participants have presented their work.
Yes, sir.
Okay, so next one. Yeah, ma'am. What?
Yes, sir.
So out of these 8 experiments which were presented in this conference, 2-3 papers are very good. They have done very good work on their research work. Some UG people's students tried to give some inputs about their projects to the participants. Presence in the conference. Initially, it was number 3132, but after that, it becomes 23. Okay, this is also a good number. So, as per the evaluation sheet provided, the evaluation is done. It will be sent to the organizer. So from my side, I am very much thankful to Dr. Dp sir for giving me this opportunity to evaluate the paper presented in the international conference. Again, thankful to Professor Sachin Chede and Dia ma'am for organizing such a good conference, given a platform to the researchers. Once again, I am very much thankful to your organization or the organization body. Thank you one and all. This is from my side. Now chair is toward the Dia ma'am.
Yes, on behalf of Department of Mechanical Engineering, Sandeep Institute of Engineering and Management, I really thank Dr. Ahir sir, who took his precious time and accepted our invitation to be a session chair for our technical session 1A. He was very keen in listening to the different presentations, although only half the number of the presentations were presented, the papers were presented. It would have been very good that all the papers were presented, and definitely sir has a definite criteria to judge the different papers. Accordingly, he appreciated 2 or 3 papers. The work is really worth appreciating, and let us hope for the best. May the best of the researcher get the best paper award. Thank you very much, Ahir sir. Fortunately, I would like to mention that sir is my Master of Engineering guide also. I know the way he's working. He like to go into the depth of the things, and unless and until to his satisfaction level, things are being operated, he will never accept the things as it is. And fortunately, our paper is also getting published. The acceptance we have received from elsewhere. And very soon, I'll send the copy also to sir. So thank you very much once again, sir.
Many congratulations to Professor Chede sir.
Yes, sir. Yes, sir.
It is your devotion, hard
yes,
work.
Sir. Yes, it actually took a long time to get it published, but somehow all the hurdles are cleared and the acceptance I have received. Very soon it will be available online also. So thank you very much, sir. And once again, I would like to thank the IFERP team also to organize such conferences and promoting best papers being published in reputed journals. Really, this is worth very good helping hand to various researchers, that they are providing a platform and the papers are being published in good indexed journals. This is really, really nice. So again, I thank IFERP also on behalf of Department of Mechanical Engineering to always get associated with us. This is almost the 3rd time we are getting very good response nationally as well as internationally. So thank you very much, ma'am, dear ma'am. Over to you.
Thank you, one and all.
Thank you, sir. Yeah, ma'am. So काहीतरी नेटवर्कचा प्रॉब्लेम वाटतं, ते गायब झाले.
Chede sir. Chede sir. Hello. Chede
Yes, sir.
In chatting, there is one question. What about the 1C? What about
Yes, sir.
the other papers?
Yeah, session 1C will be merged over here now. I hope so, because this is a session 1A is being streamlined live on YouTube. So this will be carried forward. Some other sessions will join this track. So with your permission, Dia ma'am, can we take your leave now? Hello.
Yes, sir. So we need to wait for some time. Other participants will be joining in the main room.
Yeah, but Ahir sir and me shall be there, or some other
Other zero will be available.
Will be there.
Hello, sir.
Hello.
Yes, sir. Actually, we have one more participant. Name is Kripali Kanekar. She wants to present in this session.
Okay, okay. Ayar sir, are you
With
there?
your permission, can I ask her to present, sir?
Yeah, yeah. Dear ma'am, shall we continue Ayar sir as our session chair over here for this
Yes,
paper?
sir. Yes, sir.
Okay, okay.
Parliament, please share your screen.
Yes, yes. Good afternoon, all of you.
Good afternoon, ma'am.
Actually, I am from 1C group.
Okay.
Okay, I'll share my screen.
Yeah.
Is this visible to you?
Yes, ma'am, it is visible.
Okay, so shall I continue?
Yes, yes, please go ahead.
Okay, okay. Good afternoon, all of you. I'm going to present the topic that is nothing but the estimation of seasonal variation in the model temperature model coefficient for HIT photovoltaic technology module. And I'm doing this work along with Dr. Prakash Burade, sir, Dr. Rahul Agarwal, sir, and Dr. Dheeraj Magre, sir. So here I'm going to discuss these topics. First, I'll give you the intro and the abstract. Then I will discuss about the literature review, gap, then problem formulation, methodology, and at the end, result and conclusion. So if you will consider the today's scenario, so oil crisis is the biggest problem. So it is necessary to create the awareness or the attention about the different types of alternate energy source. So that is basically required so that we can reduce the carbon footprint, so that we can avoid the greenhouse gases and we can avoid the environmental damages which is taking place, right? So nowadays the climate is continuously changing because of this pollution and the advancement in technology and all. So that will be, you can consider as a natural disaster. So if you will see the rainfalls, heaviest rainfall on one side of the country or the world, and the other part you can say the drought. So it is necessary that we have to consider the renewable energy source. If you will consider the solar energy source, the main advantage you can say, the no moving parts it will be contained. So because of that,
Hello,
the
excuse me,
maintain.
ma'am.
Yes.
Hello.
Yes.
Ma'am, your slides are not moving actually.
Yes,
The first
yes,
slide
yes.
is only visible.
Yes, yes, I am
Okay,
displaying
okay. Yeah,
first.
okay.
Is that introduction motivation slide is able to see?
No, ma'am. Only the first title slide
Oh.
is visible. Yeah, now it's okay.
Okay. Is it changing now?
Yes, we are able to see the introduction side, motivation of the research topic.
Now are you able to see abstract slide?
No.
Oh, so I have to keep in this mode only. I don't know what is the problem.
Yeah, now the abstract was visible.
Okay, I'll keep in this way only, in this mode only.
Yeah.
Otherwise it's not toggling. Fine. So the renewable energy, as we are considering the solar, because it's not having any moving parts. So because of that, it's required the very little maintenance or the less maintenance, right? So if we will consider the environmental condition, that environmental conditions is continuously varying with respect to the solar module or photovoltaic module. So because of that, what will happen? It will be affect the performance of the solar cell. Deterioration is taking place, and because of that, that will be get impacted to decrease in the output power. And that is basically depend on your variations in the temperature, model temperatures, right? Irradiance, all this factor we have to consider. So because of that, that will be affect to the electrical output power of PV cell, or we can say the photovoltaic cell. So it is necessary to predict the model temperature or the effect of the model temperature or the irradiation or the different weather conditions on the particular module solar cell. So when we are considering, normally we are considering the STC, that is standard test condition, when we are checking any solar cell in the laboratory. So normally we used to consider the STC, that is nothing but the standard test condition. So for that we are considering the irradiance is approximately 1000. And the value for temperature, that is 25 degrees Celsius. But for day-to-day life or for practical purpose, we are not able to achieve or consider that STC. We have to consider the the real-time scenario. So it is necessary that to trace out the performance of your PV module in the environmental condition. So for this reason, we will require the precise modeling approach. Okay, we will require the modeling thing. So the main objective of that modeling is we can estimate the electrical behavior with respect to the practical aspect, so that we can find out or note down or trace out the changes in the environmental parameter like irradiation and the temperature. So as the faster growth is taking place, so new standards are coming into picture with respect to the solar technology. So forecasting power output or the energy generation for better investment decision planning, maintaining better infrastructure for the energy. So when we are designing any plant, a solar plant, so it is necessary that to find out the previous literature with respect to that particular type of technology, that may be the amorphous, that may be the crystalline and all, right? So we will consider the various parameter that I have mentioned over here. We can consider the temperature, we can consider the wind speed, then we can consider the intensity or radiance, and at the same time the distribution. So with respect to the solar cell, actually it's classified into the number of category. You can say multicrystalline, amorphous, and the HIT, heterojunction intrinsic thin film. So I am going to present the effect based on HIT technology. So this is the working, how exactly the solar cell will be work when the sunlight will be fall on the first layer, that is nothing but the anti-reflection coating. So what will happen, it's consisting of basically PNN type material. So when it will be fall on that, then it will be try to absorb the sunlight. Okay, so it will be undergo the various phenomena like reflection, absorption, generation, separation, and collection. The main thing is that we have to consider the energy gap. So when your photon energy will be greater than Eg, so it is going to strongly absorb. Otherwise, it is going to absorb weakly. So the most favorable condition in our case, that is nothing but the EPH, that is photon energy should be greater than band gap energy. Then only it is able to capture or absorb all that radiation which is coming from the sun. So here I have mentioned the basic diode equation. So when we are considering the solar cell, you can consider the single diode solar model, then double diode solar model, triple diode, and then we can consider the solar module. Okay, so when we are considering the single diode, so we are simply using one diode. The construction I have mentioned over here. So you will have simply one diode, and the photon or the light energy will be fall on that particular diode, and with respect to that model, the current will be get generated using that particular equations, standard equations. Fine. Similarly, for two diode model, we have to consider the two diode, and similarly, you will get the current which will be flow through this circuit. Then when we are considering the PV module, so basically my work is based on the PV module only. So here we are considering actually the number of or the combinations of the diodes that we are connected in series and the parallel. Right? So different terms which will be involved in that are nothing but the short circuit current, open circuit voltage. Okay. So with respect to this graph, we can find out that parameters, and we have to consider the parasitic resistance also. That may be the series resistance, or that may be the shunt resistance. With respect to the literature review, I have mentioned the international status with respect to the solar energy. So here I have mentioned, as considering the importance of the green energy technology, our prime minister proposed, the one mission that will become under ISA, that is International Solar Alliance. And it is they are going to consider all these readings and details which is placed at the Gurgaon. Then they are planning to generate the 398 gigawatt energy uh, in 2017. In 2080, they proposed around 300 megawatt energy. Okay, when we are considering the South Africa scenario, so they have proposed the installation up to 1329 megawatt and all. With respect to China, they propose the 100 gigawatt and all. So that is about international status. So when we are considering the national status, we are actually following the JNNSM mission, that is Jawaharlal Nehru National Solar Mission. So they have targeted around in 29.55 gigawatt energy generation target they have kept. And along with JNNSM and TPC Vidyut Nigam, they are also working on the same solar system, so that to commission the grid connected solar power projects. If you will see at the Gujarat, we are having the government developed the solar PV village, right? Then the UMPP, that is in Rajasthan, they have proposed the ultra mega green solar power plant. In Usmanabad also we are having the generation plant. Then we are having the National Center of Photovoltaic Research and the Education at IIT Bombay. So all this scenario related to national status. So gap and contribution, if I'll say, the performance analysis is in different countries, they have considering all the effects and they have worked on that. But in India, very less amount of work is proposed with respect to this area. So here, in many literature, they are not considered the wind speed and all. So here I have considered the wind speed effect also. Okay. So here what we are considering, the number of unknown parameter, if you will see increases, then the equivalent circuit of the model become more and more convenient, right? So we are assuming that the physical nature of cell behavior, we have to consider that. So for that we are considering the mathematical modeling of model, so that we can easily understand the working. So this is the flow chart, right? So we have to consider, suppose we are having a particular panel. Now in my case, HIT panel. So with respect to HIT panel, I retrieve the reading with respect to the irradiance, ambient temperature, wind speed, humidity, and all. These are nothing but the environmental factor. Okay, that will be not come under the STC parameter. So we have to consider that real time factor or the parameter. Okay, and we are going to give that factor. We will obtain that factor from the PV model, and we will try to optimize that parameter or the coefficient. So I have taken the reading from this site, you can say, that is situated at Gurgaon. So in that, what we are having the data with respect to the wind speed, with respect to the temperature, with respect to the irradiance and all. So that data we are actually going to collect, and we are feeding to the data logger. So data logger, what it will be do with respect to the technology, it will be perform the operation on that, and finally it will be proceed that data. Right. So we use the number of equipment for measuring the, or sensors, you can say, for measuring the things. So pyranometer, here I have mentioned the specification with respect to the equipment, right? Pyranometer, then the spectrodiameter, wind sensor, humidity. For measuring all this parameter, we consider this sensor. The specification or the resolution I have mentioned over here, that is nothing but the standard things. So in my model, I use it, in my modeling, I use this equation P max. So what actually I'm doing, I'm using the, G, that is nothing but the irradiance area. That area will be vary with respect to the technology. Now for HIT, that will be 0.33. For different technology, that will be 0.3 and so on. So we are going to consider that A. Okay, then irradiance factor. Then GSTC, that will be the standard, that will be the 1000. Right, and then we are going to consider the VW, that is a wind speed. Okay, then the STC power, that is standard power for the standard testing condition or the test condition. Okay, then the gamma, that is a factor, you can say, we are going to consider. So once I know all this reading except my coefficient, that will be vary from A1 to A6, right? So what I'll try to do, I know that p value from the reading I will get, but I am unaware about that A1 to A6 value. So what I'll do, I'll try to minimize that A1 to A6 value in a such a way that I will get the optimized thing. So using the regression method, I will try to find out that A1 to A6 values. Once I'll get the A1 to A6 value, what I can do, I can predict the future thing, or the predict the P for particular G, or particular, you can say, the wind speed and all. Okay. So power coefficient obtained by using the regression analysis, I have mentioned on here, and I consider the 4 seasonal variations. In literature, they have mentioned by considering the Indian environment, we have to consider the 4 seasonal variations. So similarly, I have considered the 4 seasonal variation: monsoon, post monsoon, winter, and the summer. So with respect to that variations, I try to find out the coefficients from A1 to A6. I have mentioned the meaning: A1, A2, that is related to power, A3, that is related to the irradiance, A4, that is related to the temperature, wind speed, and A6 is constant. So with respect to the season, I have found out the various coefficients or parameters, I can say, from A1 to A6. So here I try to plot the graph by considering the A1 to A6. Okay, here the dotted line is nothing but the major reading, the reading which is obtained from the instrument. Okay, say for example, this I can explain this thing. Okay, so what we are doing, this yellow line, you can say this is a for winter reading. Okay, so this is a predicted one, solid one, and the dotted one, that is nothing but you can say the major one. So here it's matching almost, you can say, the predicted value and the value which is obtained uh, uh, from the equipment or instrument. Okay, so with respect to the season, I mentioned the variations in the graph. I have proposed a variation in the graph, so that is related to the temperature variation. This graph is related to temperature variations, and similarly I have proposed for the output power variations. Then I have found out the RMSE, root mean square error, by considering the predicted and the observed value. So square root of mentioned value minus observed value square. Using that, we can find out the RMSE value. I found out RMSE for temperature, similarly for power, and that I found out for 4 seasons. Right? So that is about my project or my work. Thank you. Thank you very much.
Krupali, very good work you have done.
Thank you, sir.
So, are you a student of UG, PG, PhD?
PhD. I'm
PhD
actually
from?
faculty and a student of PhD in Sandeep University. I'm doing.
Okay, okay, good, good. Work is appreciable.
Thank you, sir.
Go ahead, go ahead. Who is your guide, please?
Actually, Rahul sir was my guide, but now it changes from Rahul sir to Buradi sir.
Okay, no problem, no issue. So there is no question from my side. Anyone want to ask question to ma'am, please ask. Good work.
Thank you. Shall I stop sharing?
Yes, ma'am. So can I call the next presenter?
Okay, thank you very much, all of you. Thank you.
Thank you, ma'am. Yes, sir, can I call the next presenter with your permission?
Yeah, how many presenters are there, madam?
Sir, only one presenter right now.
Okay, but the problem is we both are from mechanical fraternity and it will not be justice to judge. So this last presenter is from which branch?
Sir, branch, it's like computer. CT.
Okay, with permission of IR sir, shall we go ahead? The last one. Hello?
It's permission from organizers also.
Yes,
Whether it is permissible to have interacted jury members or
actually
if there is no any issue, please go ahead.
Yes, the last one, sir. Thank you very much, sir.
Okay.
Thank you, sir. Thank you, sir. I would like to call Abhinav P, sir, for presentation on analysis of COVID-19 lung computed tomography scan image using segmentation. Abhinav, sir, are you present there? Am I audible to you? Abhinav, sir? Yes, sir, you can present your work. Avinash, sir.
Hello. Ma'am, can you hear me?
Yeah, I can hear you, ma'am.
Ma'am,
Ma'am, please make your sound clear.
ma'am, I'm in technical 1C section, ma'am.
Okay.
I present my presentation, ma'am.
Yeah, you can present your presentation.
Okay, ma'am. Can you see my presentation, ma'am? Hello.
Yes, ma'am. Yes, ma'am. You can proceed.
Good afternoon, everyone. My work is analysis of COVID-19 computer tomography images using segmentation process. My guide is Dr. N. Sanjay Kumar, ma'am, head of the department, and also my course guide is Prem Kumar, sir, assistant professor of the department, and I'm studied Knowledge Institute of Technology. And my main what is the reasons for taking this work? Means due to the reason as a project to work in this field, and I want to recognize the COVID-19 diseases from the people who have symptoms of COVID-19, and this is a very important. This is very important in those days to identify the corona COVID-19. So it's an early stage; it's not possible. So there are several approaches have been proposed, and so I proceed this type of false cases I have to reduce. It's my main objective, and I have to go to present as abstract instructions and block diagram and methodology and results. And abstract, what is my main abstract is to detect the COVID-19 using an CT scan images by using a segmentation process, and CT scan images are available in a public database, and I will take it from for pre-processed and to identify the infected regions in that images, and also some performing some process to measure the metrics, and its main objective is to reduce the false positive cases by analyzing the CT images with minimal time. Next introductions. First identification of COVID-19. The reverse transcription polymerase chain reaction was introduced and for regular practice to identify the COVID-19. This is a good method, but it has taken a large time to lost time, and also given a false face cases to this report, and so then going for diagnosis of another technology. It's called an radiographic technology. There is X-ray and CD images. X-ray also a good method, but um, it is less sensitivity about it's a sensitivity about COVID-19 when compared to RT-PCR. Then going to an CT scan images, it will be a better performance in all those cases, and it is of very high accuracy and very precisable deductions, and um, no for rarely no false states. And this is my block diagram. I will taken a CT scan images to produce an enhancement technique. It's a pre-processing technique. Enhancement technique. After enhancement of images, I will put it to a free filtering technique. It's a filter to reduce the noise by Gaussian filtering technique. Then after going to an after filtering process, the images are segmented using segmentation process. I'm using a segmentation process as a threshold algorithm. And after segmentations, there will given a segmented image. It's a segmented image which is used to identify COVID-19. And it's COVID-19.
COVID-19. Next methodology. The data sets are taken from the public resources like Google. It's for usually for reduction of the COVID-19 and pre-processing techniques. We have studied. Pre-processing technique is helpful for filter, helpful for analyzing the images in the image processing technique. It will help you a lot to find out the regions. Uh, uh, find out the regions to identify the regions to identify the disease affected part. And in pre-process technique, I'm using two techniques. That is, one is the enhancement technique, another is the pre-filtering technique. Enhancement, I'm using enhancement algorithm as histogram expression, and pre-processing technique is Gaussian filtering technique. And enhancement technique is used to improve the quality and information content of the original data. The images consist of data and data in a group of frequencies, and that informations will be get in a quality form. So we take it in a in a account. And histogram equalization is used to adjust the contrast of an image by using its histogram. It to enhance the image contrast, it spread out the most frequent pixel intensity values and stretch out the intensity range of the image. And it is used for adjusting the contrast of the image um, to valued added for the images. And it is it it represents the continuous frequency distributions to enhance the images to analyze for further process. Then pre-filtering is used to alternate a noise present in the images. It is used by Gaussian filtering. It's a very much effective filtering because we take an image of using camera or any other devices, it will full of contain noise and blur image. It's possible, so it will be very helpful to alternate that noise. I'm using a Gaussian filtering, and this preprocessed data is segmented preprocessed data is used to segment used for segmentation process, and the segmentation process, it is converted an digital image into multiple segments. Digital image is nothing but it's a form of ones and zeros. The image is form of ones and zeros that extract the particular features of that city images to identify the disease affected part. The threshold algorithm is thresholding
Yes.
thresholding algorithm is to change the pixel of an image to make the image easier to analyze. So it is we fix a threshold. It's a range between the for fixing the threshold value. It's take up to threshold value it take as a 0, and after the threshold value it is take as 0 by calculating like this. It will give an results like this. This is the image shown here. Is first is an CT scan image. It's a database image, and after enhancement technique, it will be enhanced to view gray color, gray and white color, and it was it is either in a process to pre-filtering technique, and it is pre-filtered by Gaussian filter to accurate spectral noise. And after the filtering process, it is carried to the threshold algorithm to execute an segmentation process by using a threshold interval. And a segmented image is particular to extract the image from the extract image from the background image. And this is the segmentation image I have obtained for this project. I'm using this, I'm getting this type of images by using an I've learned it's analysis software. It is very useful and it is a very user guide to image analysis. These are references I have referred for this book. Thank you.
Okay, good. Ma'am, where is technology is used in actual practice? Whether it is in use in hospitals?
It is usually in research industries. So in research industry, they are going to an this identifications of COVID-19
Okay.
identifications.
Research industries mean you meant to say that the vaccine manufacturers are also making use of this?
Not like that, sir. Vaccine, not, but it is used in to identify the COVID cases, sir.
Yeah,
Based
yeah.
on scan images.
Yeah, but if this root level study is done, then the vaccine manufacturers can also get some inputs regarding the vaccine. Or it is a totally different part. I mean, after identifying with these images, if the COVID-19 is detected, then there might be some remedies also. No?
Yes, sir, but
so it is not correlated as such.
So, please can you ask the question again?
Yeah, I mean to say is when it is detected, to cure that, there might be some correlation of this study being conducted with the vaccine being proposed for curing this COVID-19 at this stage, if lungs are getting infected.
Might be, sir. It will detect the identified part. Its main objective is to reduce the false cases because lungs disease can be considered as COVID-19 in during those days. So that's why only I'm taking this as a approach.
Okay, so these tests they are only meant for research study, or they will be used now in future.
Now in the research studies, or maybe it might be useful in hospitals.
Okay.
Because it will lead to an artificial intelligence based type to identify on COVID-19. It leads to like.
But you need to go for validation also. No? There might be some agency who will be validating these tests.
Yes, sir.
Okay. Okay, ma'am. It's very in-depth, detailed work.
Can I stop sharing, sir?
Yeah.
Yes, please.
Thank you so much, sir.
Anyone is interested to present paper?
Hello.
Sir? Hello.
Hello. Yes, sir. I'm Ms. Nandini Bhandari. I would like to present the paper.
But you are a group, ma'am?
I'm from electronics, sir.
Jade, sir?
Yes, sir.
She is from electronics group.
Yes. I have asked the coordinators to come into the picture, so they will intervene, sir.
Yes. So it will be justice to the students.
Yes, sir. Yes, sir.
We will wait for some time.
Yes, sir. Please.
Hello, sir. Hello. Sir, can you hear me?
Yes, please, ma'am.
Yes, sir. We can wind up the session, sir.
Chede, sir.
Thank you so much, Vishnu Iyer sir and Sachin sir, for sessioning the chair. Thank you, sir, for your valuable time.
Okay, thank you very much, ma'am.
Thank you. Thank you
Thank you so much, sir.
for giving chance.
Thank you, sir.
I want to thank you everyone for participating in the conference. Thank you for your valuable presentations. That's it. Okay.